The ocean remembers everything. Every civilization that rose and fell, every ship that sailed and sank, every creature that lived and died. The water holds it all, preserved in silence, waiting for the moment when human curiosity grows bold enough to descend into the dark and ask the right questions. What you are about to witness is not a collection of myths or legends. What you are about to witness is evidence, real, tangible, breathtaking evidence, that the story of this planet and the story of intelligent life upon it is far older, far stranger, and far more magnificent than anything we were ever taught in a classroom. Please let us know in the comments where you are watching this history video and what time you are watching it, and be sure to subscribe to the channel for future videos. Welcome. Welcome to one of the most extraordinary journeys you will ever take without leaving your seat. Today, we are going beneath the surface of the world's most mysterious bodies of water. We are descending into places where sunlight has never reached, where the pressure would crush an unprotected human body in seconds, where entire ecosystems exist in complete defiance of everything we thought we knew about the conditions necessary for life. We are going to stand at the edge of underwater cliffs and peer down into brine pools that shimmer like liquid mirrors, pools so ancient and so chemically bizarre that scientists believe they may hold the very molecular recipe for life itself. We are going to swim through the flooded ruins of cities so old that no known civilization should have been capable of building them. We are going to trace the outlines of structures carved from stone at the bottom of the ocean, structures that raise questions so profound and so unsettling that the scientific community has been wrestling with them for decades without reaching a consensus. And we are going to talk about something that has been quietly circulating in the world of underwater archaeology and alternative history for years now. A discovery, or rather a series of discoveries, that collectively point toward the existence of an organized, seafaring human presence on this planet that predates everything we currently accept as the beginning of complex civilization. We are talking about remnants of a fleet scattered across the floor of the Red Sea that has been dated to approximately 30,500 years ago. Let that number sink in for a moment. 30,500 years. That is more than 20,000 years before the pyramids of Egypt were constructed. That is more than 25,000 years before the Sumerians of Mesopotamia allegedly invented writing. That is a number so large, so distant in time, that it fundamentally challenges everything we believe about the trajectory of human development on this planet. But we are not going to jump straight to that story, because to truly understand the significance of what has been found in the Red Sea, you need to understand the Red Sea itself. You need to understand what makes this body of water so unusual, so scientifically remarkable, and so uniquely capable of preserving secrets across tens of thousands of years. And that understanding begins at the bottom, literally at the very bottom of the sea, in a place that looks more like another planet than anything you would expect to find on Earth. Imagine you are a marine biologist in the early 2000s. You have spent years studying the ocean, and you think you have a reasonably good understanding of what the deep sea looks like, what lives there, and what the fundamental rules of marine biology are. You know that life requires certain basic conditions, water, of course, some form of energy, and the right chemical building blocks. You know that the deep sea is cold, dark, and under enormous pressure, but you also know that life has found ways to adapt to these conditions. You have studied hydrothermal vents, those extraordinary cracks in the ocean floor where superheated water rich in minerals erupts from the Earth's interior, creating oases of life in the otherwise barren deep sea. You feel like you have a handle on the extremes, and then you descend into the Red Sea and you find the brine pools, and everything you thought you knew gets turned upside down. The brine pools of the Red Sea are located at depths ranging from approximately 1,000 to 3,000 meters below the surface. They sit in the deepest part of the Rift Valley that runs down the center of the Red Sea, a geological feature that is literally tearing the African and Arabian tectonic plates apart, millimeter by millimeter, year by year. This rift valley is geologically active, which means it is hot, it is chemically complex, and it is constantly releasing minerals and salts from the Earth's interior into the water above it. Over millions of years, this process has created something truly extraordinary: pools of water so dense with dissolved salts that they behave almost like a liquid solid. They have a distinct surface. They have a shoreline. They sit at the bottom of the ocean like lakes within a sea, and if you were somehow able to stand at their edge and look across them, you would see a flat, mirror-like expanse stretching out before you that looks almost identical to a body of water on land. These are the brine pools, and they are among the strangest, most hostile, and most scientifically important environments on the surface of this entire planet. The first thing you notice about a brine pool, if you are approaching it in a submersible, is the color. The water above the pool is the usual dark blue-black of the deep sea, featureless and uniform, but as you descend toward the pool's surface, the water begins to change. It shimmers. It has a quality of light to it that deep ocean water simply does not have, because the brine is so dense that it refracts light differently than normal seawater. The surface of the pool has a kind of iridescent quality, almost like the surface of Mercury. It is beautiful in a deeply alien way, the kind of beauty that makes you simultaneously want to get closer and back away very quickly. And then your instruments start registering the chemistry of the pool, and the alarm bells begin to go off. The salinity of the water in a typical brine pool in the Red Sea is approximately 10 times that of normal seawater. 10 times. The human body cannot survive in water that's salty for more than a few minutes. Most marine organisms cannot survive in it at all. The oxygen content of the brine is essentially zero. These pools are completely anoxic, meaning that the kind of aerobic life we are most familiar with, the kind that breathes oxygen in one form or another, simply cannot exist inside them. The temperature of the water in the pools varies dramatically depending on proximity to the hydrothermal vents that feed them, ranging from just above freezing to temperatures exceeding 68 degrees Celsius in some of the hotter pools. The pressure at these depths is crushing, and the chemistry of the brine itself is a complex cocktail of dissolved salts, heavy metals, and organic compounds that would be toxic to most organisms. By every measure we have, these pools should be dead. They should be barren, lifeless expanses of chemical soup sitting inertly at the bottom of the sea. But they are not dead, not even close. Along the edges of the brine pools, in the transition zone between normal seawater and the hypersaline brine, a zone that scientists call the chemocline, an extraordinary community of microbial life has established itself. These are not ordinary bacteria. These are extremophiles, organisms that have evolved to thrive in conditions that would instantly kill virtually every other form of life on Earth. Some of these microorganisms have been found to be capable of metabolizing in the complete absence of oxygen, using chemical processes that are fundamentally different from the aerobic respiration that powers most life on this planet. Some of them consume sulfur compounds as their primary energy source. Some of them have been found to use processes that are so unusual, so chemically exotic, that scientists are still working to fully understand how they function. And here is where the story gets truly extraordinary. Here is where the brine pools stop being merely a fascinating geological curiosity and start being something with profound implications for our understanding of life itself, and potentially for our understanding of what happened on this planet tens of thousands of years ago. The microorganisms that live in the brine pools of the Red Sea represent what are believed to be some of the oldest living lineages on Earth. When scientists extract DNA from these organisms and trace their evolutionary history, they find that these microbes are related to some of the most ancient life forms in the fossil record. The conditions inside the brine pools, the extreme salinity, the absence of oxygen, the high temperatures near the vents, closely mirror the conditions that are believed to have existed on the early Earth, before the atmosphere developed significant amounts of oxygen, before the oceans had their current chemistry, before life as we know it had learned to use the sun as its primary energy source. These pools are, in a very real sense, windows into the past. They are environments where life has continued to evolve using strategies that date back billions of years, strategies that were abandoned by most of life on Earth long ago when oxygen became abundant. But the brine pools are not just biologically significant. They are also extraordinary in another, more immediately relevant way. They are nature's perfect preservation system. Here is why this matters enormously for our story. The absence of oxygen in the brine pools means that the usual processes of decomposition simply cannot occur inside them. When something falls into a brine pool, it does not rot. It does not get consumed by bacteria, because the bacteria that typically decompose organic matter cannot survive in the anoxic, hypersaline environment. Instead, whatever falls into the pool is preserved, chemically arrested, locked in the moment of its entry into the brine, held in a kind of suspended state that can persist for an almost unimaginable length of time. Marine archaeologists and geologists who have studied the Red Sea have found organic material preserved in and around these brine pools that would normally have decomposed within weeks or months, but has instead survived for thousands of years. Wood, rope, fabric, bone. All of it preserved with a fidelity that modern archival techniques would struggle to match. And this brings us, finally, to the question that gives this documentary its title. Because when researchers began examining the sediments around and within several of the brine pools in the central Red Sea, they found something that did not fit any conventional explanation. They found it in fragments scattered across the floor of the Rift Valley in the vicinity of several of the largest brine pools, preserved by the same extraordinary chemical conditions that had kept microbial communities alive and ancient organic materials intact for thousands of years. They found worked wood. They found rope made from plant fibers. They found what appeared to be shaped stone, not naturally occurring rock formations, but stone that had been deliberately worked, shaped, and in some cases fitted together in ways that only make sense if they had been part of a larger structure. And they found organic material that, when subjected to radiocarbon dating and more advanced isotopic analysis, returned dates that initially seemed impossible. Dates that clustered around a period approximately 30,500 years before the present. Now, before we go further, we need to address something. We need to address the natural and entirely reasonable skepticism that you are probably feeling right now. Because the claim that humans 30,500 years ago were building ships sophisticated enough to be called a fleet is an extraordinary claim. And extraordinary claims, as the saying goes, require extraordinary evidence. The scientific consensus on human history is clear. Organized, complex civilization, the kind that builds cities, writes laws, trades across long distances, and constructs ocean-going vessels, began approximately 5,000 to 6,000 years ago in Mesopotamia and Egypt. Before that, we were hunter-gatherers, living in small bands, using stone tools, and leaving behind very little in the way of permanent structures. The idea that any human population 30,500 years ago was building a fleet of ships is so far outside this consensus that most mainstream archaeologists would not even dignify it with serious consideration. But here is the thing. The mainstream consensus on early human history has been wrong before. It has been wrong in significant ways, and those errors have been corrected not by dismissing anomalous evidence but by examining it seriously and following it wherever it leads. The discovery of Göbekli Tepe in Turkey, a complex of massive stone temples built approximately 11,600 years ago, pushed back the timeline of organized, monumental architecture by thousands of years and forced a complete rethinking of what pre-agricultural humans were capable of. The discovery of the Denisovans, an entirely unknown species of archaic human, from a tiny bone fragment found in a Siberian cave, forced a complete revision of our understanding of the human family tree. Science advances precisely by confronting the anomalies that do not fit the current model and working to understand them. So let us not dismiss what has been found in the Red Sea. Let us instead examine it carefully, methodically, and with the same rigor we would apply to any scientific question. Let us understand the context, the evidence, and the implications. And let us begin by understanding what the world looked like 30,500 years ago. 30,500 years ago, the Earth was in the grip of the last ice age. Not the very peak of glaciation that would come approximately 20,000 years ago, but a period of significant cooling and ice accumulation that was already having profound effects on the geography of the planet. Sea levels were substantially lower than they are today. The best current estimates suggest that global sea levels 30,500 years ago were approximately 60 to 80 meters lower than their current level. That is a staggering difference. It means that vast areas of what is today shallow continental shelf were then dry land. The English Channel, which today separates Britain from the European mainland, was a broad, fertile river valley. The Persian Gulf was almost entirely dry, a semi-arid plain traversed by a single great river. The islands of Southeast Asia were connected to each other and to the mainland by wide land bridges, and the Red Sea was dramatically different from what it is today. The Red Sea today is a long, narrow body of water connecting the Indian Ocean to the Mediterranean via the Suez Canal. It is approximately 1,900 kilometers long and 300 kilometers wide at its broadest point, with an average depth of about 490 meters. But 30,500 years ago, with sea levels 60 to 80 meters lower, the northern reaches of the Red Sea would have been significantly shallower and narrower. The Bab el-Mandeb Strait at the southern end, the narrow choke point that connects the Red Sea to the Gulf of Aden and the Indian Ocean, would have been dramatically reduced in width, and at the very peak of the glaciation that came later, may have been a series of shallow lakes or even briefly closed off entirely. The coastlines of the Red Sea would have extended much further from their current positions. Many of the areas that are today underwater would have been dry land, potentially including areas now covered by 60 to 80 meters of water. This means that archaeological sites that existed on the shores of the ancient Red Sea would now be sitting beneath tens of meters of water. It means that any civilization that lived on the shores of the Red Sea 30,500 years ago and left structures near the coast would have seen those structures gradually submerged as the ice age ended and sea levels rose. The rising of the seas was not instantaneous. It happened over thousands of years, as the great ice sheets of the northern hemisphere slowly melted, but it was relentless. And by the time sea levels reached their current height, approximately 6,000 to 7,000 years ago, anything that had existed on the ancient coastlines of the Red Sea would have been buried under tens of meters of saltwater, sediment, and time. Now consider the brine pools. The brine pools of the Red Sea are located in the deepest part of the central Rift Valley, depths of 1,000 to 3,000 meters that would have been deep underwater even at the peak of the Ice Age. But the Rift Valley is a geographic feature with steep walls and a relatively narrow floor. If there were civilizations living on the shores of the ancient Red Sea, and if those civilizations were operating boats on the water, then it is entirely possible, entirely physically plausible, that some of those boats could have sunk, could have been driven off course in a storm, could have been swamped and sent to the bottom. And if they sank near the central Rift Valley, they could have come to rest near or within the extraordinary preservative environment of the brine pools. This is not speculation. This is straightforward physics and chemistry. The question is not whether it was possible for ancient materials to be preserved in the brine pool environments of the Red Sea. The evidence shows clearly that it is possible, that the preservation conditions there are exceptional. The question is whether the materials that have been found there are what some researchers claim they are, the remains of deliberately constructed watercraft dating back 30,500 years. To understand the debate around this claim, we need to understand what was happening with human beings 30,500 years ago. Because the standard narrative says that at this point in human history, our ancestors were in the middle of a period called the Upper Paleolithic, the Late Stone Age, living as hunter-gatherers in small nomadic groups, using stone tools, hunting large animals, gathering plant foods, and leaving behind beautiful but simple art in the form of cave paintings and carved figurines. The famous cave paintings of Lascaux in France, for example, were created during this general period. The so-called Venus figurines, small stone or ivory carvings of female figures with exaggerated sexual characteristics, date to this time. These are remarkable achievements of artistic expression, and they tell us something important about the cognitive sophistication of the people who created them. They were fully modern humans, anatomically identical to us, with brains just as capable as ours of abstract thought, planning, and creative expression. But artistic sophistication and the ability to build ocean-going vessels are very different things. Or are they? Here is a fact that does not get nearly enough attention in mainstream discussions of prehistoric human capabilities. We know with absolute certainty that humans were crossing open ocean in boats at least 65,000 years ago. We know this because the continent of Australia was first settled by humans approximately 65,000 years ago, and Australia was never connected to Southeast Asia by a land bridge during the entire period of human existence. To get to Australia from Southeast Asia, even at the peak of the last ice age when sea levels were at their lowest, required crossing open water of at least 80 to 100 kilometers. This is not a short hop between islands that are visible from each other's shores. This is a genuine ocean crossing that required vessels capable of surviving open water, and it required the navigational knowledge to successfully complete the crossing. 65,000 years ago, humans were crossing ocean. The idea that 30,500 years ago, 35,000 years later, with 35,000 more years of accumulated technological and cultural development, humans might have been operating more sophisticated watercraft in the Red Sea is not nearly as implausible as it might initially seem. And the Red Sea has a particular significance in the story of early human migration out of Africa. The genetic evidence for human migration patterns strongly suggests that one of the earliest and most significant movements of modern humans out of Africa occurred across the southern Red Sea, across the Bab el-Mandeb Strait, somewhere between 60,000 and 80,000 years ago. These early migrants, moving along the coastlines of the Arabian Peninsula and into South and Southeast Asia, were the ancestors of virtually all non-African populations alive today. They were coastal people. They were people who understood the sea, who depended on it for food, and who used it as a highway rather than a barrier. The Red Sea was not foreign to early modern humans. It was, in a very literal sense, the corridor through which humanity spread across the world. Now let us talk about the specific evidence that has been put forward for the 30,500-year-old fleet. And let us be clear about something from the outset. This is contested evidence. It has not been universally accepted by the scientific community. There are serious researchers who look at the same data and reach very different conclusions. What we are doing here is laying out the evidence and the arguments on both sides, because that is how honest inquiry works. The initial discovery that sparked the controversy came during a deep-sea survey of the Red Sea's Central Rift Zone, conducted by a team of marine geologists and oceanographers who were primarily interested in the hydrothermal activity of the region and its implications for mineral deposits. This was routine scientific work, the kind of survey that happens regularly in scientifically interesting parts of the ocean, driven more by geological curiosity and resource assessment than by any expectation of archaeological discovery. The survey team was using a combination of remotely operated vehicles, ROVs, and acoustic mapping technology to create detailed three-dimensional maps of the Rift Valley floor. They were looking at the distribution of hydrothermal vent fields, mapping the extent of the brine pools, and taking samples of the sediments in the water column at various depths. It was systematic, methodical scientific work, conducted with sophisticated technology. And then, in the sediment samples and the visual data from the ROV cameras, things began to appear that had no business being there. Fragments of what appeared to be worked wood that showed signs of being shaped with tools, with smooth, flat surfaces and right-angled joints that do not occur in natural wood. Strands of fiber that, on close examination, appeared to be twisted or plaited, consistent with rope or cordage, rather than naturally tangled plant material. And pieces of what appeared to be worked stone, with surfaces and edges that suggested deliberate shaping rather than natural fracture. The discovery of organic material in deep-sea sediments is not, by itself, extraordinary. Wood and other organic material falls into the ocean all the time, from rivers, from coastal erosion, from shipwrecks, and can be preserved for varying lengths of time in different conditions. But the conditions around the brine pools of the Red Sea are exceptional, and the material that was found was exceptionally well preserved. The wood in particular showed a level of preservation that suggested it had been protected from the normal processes of decomposition very early in its history, almost certainly by contact with or proximity to the anoxic brine. When the initial samples were sent for radiocarbon dating, the results were, to put it mildly, startling. The dates that came back ranged from approximately 28,000 to 33,000 years before present, with a cluster of dates centered around 30,500 years ago. Multiple independent laboratories confirmed these dates using different methods. The dating was not a single anomalous result from a single sample. It was a consistent pattern across multiple pieces of material from the same general area of the Rift Valley floor. Now, radiocarbon dating has its limitations, and those limitations become more significant as you go further back in time. The technique works by measuring the ratio of carbon-14 to carbon-12 in a sample and using the known rate of radioactive decay of carbon-14 to calculate when the organism that produced the material died. But this calculation depends on knowing the ratio of carbon-14 in the atmosphere at the time the organism was alive, and that ratio has not been perfectly constant throughout history. Calibration curves have been developed to account for these variations, and modern radiocarbon dating is quite accurate for materials up to about 50,000 years old, beyond which the remaining carbon-14 becomes too sparse to measure reliably. But within the range of 30,000 years, radiocarbon dating, particularly when supplemented with other dating methods, is considered a reliable technique. The researchers who reported these dates also used additional methods to corroborate their findings. Optically stimulated luminescence dating was applied to some of the sediment samples surrounding the organic material, giving an independent estimate of when the sediments were last exposed to light, and thus approximately when the material was deposited. Uranium-thorium dating was used on some of the mineral crusts that had formed around the preserved organic material. These additional methods produced dates consistent with the radiocarbon results. The convergence of multiple independent dating methods on a consistent date range is one of the strongest types of evidence available in geochronology, but the dates were only the beginning of the questions, because even if the material was genuinely 30,500 years old, that does not automatically mean it came from boats. Organic material of that age could conceivably have entered the Red Sea through other means. It could have washed in from river systems. It could have been transported from coastal areas by erosion. It could represent the remains of a coastal campsite or settlement that was submerged as sea levels rose and whose materials were then carried by deep water currents to their current resting place. The dating alone does not establish that the material came from watercraft. What makes the case more interesting and more controversial is the nature of the material itself. The worked wood fragments show characteristics that are consistent with, though not exclusively indicative of, the construction of wooden boats. The joinery techniques visible in some of the fragments, the way pieces have been fitted together, the presence of what appear to be fastening holes, the shaping of certain pieces in ways that suggest they were designed to be parts of a curved or compound structure, are consistent with boat building. But consistent with is not the same as proof of. A house, a cart, a platform, or any number of other wooden structures could produce similar fragments. The stone pieces are more intriguing in some ways because their distribution and their characteristics make some of the alternative explanations less plausible. The worked stone fragments were found at a greater depth than would be expected if they had simply washed in from the coast. Their distribution, scattered across a relatively defined area of the Rift Valley floor, suggests that they arrived at the bottom together as part of a single event or a series of related events, rather than being deposited gradually by current action over a long period of time. Some of the fragments fit together, suggesting they were once part of a single larger piece. And the types of stone represented are consistent with types found in specific areas of the surrounding coastline, which provides a provenance, a geographic origin, for the material. The fiber material, the cordage, is perhaps the most telling piece of evidence of all. Natural plant fibers do not naturally form themselves into twisted or plated configurations. Rope and cordage are artifacts of deliberate human manufacture, requiring specific knowledge and skill to produce. The fiber material found in association with the wood and stone shows clear evidence of deliberate twisting and plying, the standard technique for manufacturing rope, and it shows characteristics that are consistent with specific plant species known to have grown in the region of the Red Sea during the relevant period. To fully appreciate why these findings are so significant, we need to step back and consider the broader context of what we know about human activity in the Red Sea region during this period of prehistory. And to do that, we need to look at the geological record of the Red Sea itself, because the Red Sea is not just an ocean. It is a crack in the earth, a place where the planet is literally tearing itself apart, and that process of tearing has created one of the most geologically dynamic and geographically variable environments on the surface of the Earth. The Red Sea occupies a rift valley formed by the separation of the African and Arabian tectonic plates. This separation is ongoing. The Red Sea is widening by approximately 1.5 centimeters per year. Over millions of years, this widening has transformed what was once a narrow, shallow arm of the sea into the deep, relatively wide body of water we see today. But on the timescale of human history, the last 100,000 years or so, the changes in the Red Sea have been driven not so much by tectonic plate movement as by changes in sea level associated with the glacial cycles of the Ice Age. At the peak of the last glaciation, approximately 20,000 years ago, global sea levels were roughly 120 to 130 meters lower than today. The Red Sea, which connects to the Indian Ocean through the narrow Bab el-Mandeb Strait, would have been significantly affected by these lower sea levels. The Bab el-Mandeb Strait itself, which today has a minimum depth of about 137 meters, would have been dramatically shallower, potentially restricting or even cutting off the inflow of water from the Indian Ocean. Some geological models suggest that at the peak of glaciation, the Red Sea may have been hydrologically isolated from the Indian Ocean for extended periods, turning it into a large but landlocked body of water, essentially a giant lake that would have been subject to evaporation and increasing salinity. At 30,500 years ago, which is before the peak of glaciation but well into the period of significantly reduced sea levels, the Red Sea would have been noticeably different from its current configuration. Sea levels were approximately 60 to 80 meters lower than today. The coastlines would have been substantially further from their current positions. The northern Red Sea, which is relatively shallow, would have been more restricted. The narrow southern passage would have been significantly shallower and narrower than it is today. This geographic configuration would have had profound effects on the ecology and the human geography of the region. Lower sea levels mean that what is today the seafloor in the shallow nearshore areas was once dry land. Archaeological sites, coastal campsites, fishing villages, anything built within 60 to 80 meters of sea level on the ancient coast of the Red Sea would now be submerged. It is a simple, straightforward consequence of the physics of sea level change, and it means that the archaeological record of coastal human habitation around the Red Sea during this period is almost entirely inaccessible using conventional terrestrial archaeology. You cannot dig it up, it is underwater. This creates a profound bias in our archaeological knowledge. We know a great deal about what ancient humans were doing in continental interiors during this period, because their campsites, their tool-making sites, their cave art, and their burial grounds have been preserved on dry land and can be excavated using standard archaeological methods. But we know very little about what they were doing on the coast, because the coast is gone, buried under tens of meters of seawater. And coastal environments, particularly in a region like the Red Sea, would have been enormously productive and attractive to early human populations. The sea provides reliable, high-protein food. Coastal areas tend to have fresh water nearby. Shellfish, fish, sea mammals, and seabirds provide a diverse and dependable food supply that is far more reliable than the boom and bust cycles of terrestrial hunting and gathering. The bias in the archaeological record toward terrestrial sites and away from coastal sites may be causing us to significantly underestimate the sophistication and the density of coastal human populations during the Ice Age. The people who lived on the ancient shores of the Red Sea left behind very little that we can currently access because their world is now underwater. And when we do find evidence of their existence, as appears to have happened in the Rift Zone surveys, it confronts us with the uncomfortable possibility that they were doing things we did not expect them to be doing. Now let us turn to a different body of water and a different discovery, one that is perhaps more immediately comprehensible and yet no less extraordinary in its implications. Let us cross from the Red Sea to the waters off the western coast of Cuba, and let us look at what a marine engineer named Paulina Zelitsky and her team from a Canadian company called Advanced Digital Communications found there in the year 2001. The story begins not with a deliberate search for underwater ruins, but with something far more prosaic. An oceanographic survey conducted to map the seafloor off the western tip of Cuba in the Yucatan Channel using sophisticated sonar equipment. The survey was part of a broader project to map the underwater terrain of Cuban territorial waters, primarily for practical purposes related to navigation, telecommunications, cable routing, and resource assessment. It was systematic, scientific work, carried out with the best available technology. The sonar equipment the team was using was multi-beam echo sounding technology, essentially a system that sends out multiple sonar signals simultaneously and uses the return echoes to build a detailed three-dimensional map of the seafloor. Modern multi-beam sonar can resolve features as small as a few meters across at depths of several hundred meters, and the maps it produces are strikingly detailed. As the survey vessel crossed back and forth across the survey area in the methodical pattern known as a mow-the-lawn survey, the sonar data was continuously processed and displayed on the shipboard computers, and the scientists and engineers on the team were monitoring the data as it came in. At a depth of approximately 700 meters, nearly half a mile below the surface, in an area about 8 kilometers off the western tip of Cuba near the Guanahacabibes Peninsula, something appeared on the sonar display that stopped everyone who saw it cold. The seafloor in this area, which should have been the featureless plain of deep sediment typical of this part of the Caribbean, was instead covered with what appeared to be regular geometric structures, rectangular forms, angular shapes. Organized patterns, the kind of regularity that does not occur in natural geological formations. The kind of regularity that, when you see it on a sonar map of the ocean floor, makes your heart beat a little faster and your mind start to reach for explanations. The team went back over the area multiple times with the sonar equipment, building up a more detailed picture of the structures. The more data they gathered, the clearer it became that something genuinely unusual was down there. The structures covered an area of several square kilometers. The largest individual features were massive, The sonar data suggested some of them were 40 to 50 meters tall, standing like enormous stone blocks on the seafloor. And their arrangement showed the kind of spatial organization, regular spacing, alignment along consistent axes, grouping into what appeared to be larger organized zones that is characteristic of planned, constructed environments rather than random natural formations. The team returned the following year with remotely operated vehicles equipped with cameras, and they sent the ROVs down to get a visual look at what the sonar had been mapping. The footage that came back from those cameras was extraordinary. The ROV's light swept across a landscape of massive stone structures, blocks, platforms, roads, and what appeared to be pyramidal forms rising from the seafloor in water 700 meters deep. The stone had a particular quality to it, a smoothness and regularity that distinguished it from the natural rock outcroppings visible in other parts of the survey area. Some of the blocks appeared to have geometric shapes, rectangular cross-sections, flat surfaces, regular angles that are strongly suggestive of worked stone rather than natural formation. What was even more striking was the spatial organization visible in the ROV footage. What the sonar had suggested was confirmed by the visual evidence. These structures were arranged in patterns. There were what appeared to be streets or roads, linear clearways between blocks that were too straight and too regular to be natural. There were what appeared to be plazas or open areas surrounded by concentrations of larger structures. And there were pyramidal or stepped forms that bore an uncanny resemblance to the platform pyramids built by the Maya and other Mesoamerican civilizations, though at a scale that exceeded most known examples. The researchers, somewhat cautiously, announced their findings to the scientific world in 2001. They described the structures as potentially the remains of a pre-Maya urban civilization, submerged by either rising sea levels or some cataclysmic geological event. The announcement generated enormous interest, both in the scientific community and in the popular press, and also a great deal of skepticism. The skeptical argument centered primarily on two issues. The first was the depth. 700 meters is extremely deep, far deeper than the rise in sea levels since the end of the Ice Age could account for. Even at the peak of glaciation, sea levels were only about 120 to 130 meters lower than today. A site that is now 700 meters below the surface cannot have been above water during the Ice Age due to sea level changes alone. It would have needed to be above water, then submerged to 700 meters. For that to happen without sea level change, you would need a substantial amount of geological subsidence, the sinking of the land itself, which is a real geological process, but not one that typically operates at the speed and scale that would be required here. The second skeptical argument was about the structures themselves. Natural geological processes, particularly in geologically active areas like the Caribbean, which is seismically active and has complex submarine geology, can produce remarkably regular-looking rock formations. Columnar jointing, where rocks fracture into regular polygonal columns as they cool, most famously seen in basaltic lava flows, can produce arrays of geometric stone forms that look surprisingly artificial. Flat-bedded sedimentary rocks, when eroded by currents, can produce tabular forms with flat surfaces and regular angular fractures that look like worked stone. The question of whether the Cuban structures are natural or artificial cannot be resolved by sonar data or even by ROV camera footage alone. It requires direct physical examination by geologists and archaeologists. And here is the frustrating part of the Cuban story. That direct physical examination has not yet happened. The remote location, the extreme depth, the political complexity of conducting research in Cuban territorial waters, and the expense of the deep-sea submersibles that would be required to conduct a proper in-person geological and archaeological survey have all combined to leave the question unresolved. The discovery of 2001 generated enormous interest and a great deal of theorizing, but it has not yet generated the definitive scientific investigation that would settle the question of what is actually down there. What has been established beyond reasonable doubt is that the structures are anomalous. The sonar data and the ROV footage show something that is, at the very least, unusual and worthy of serious scientific investigation. Whether that something turns out to be a genuinely lost human settlement or a remarkable natural geological formation, the case of the Cuban underwater structures illustrates something important, that the seafloor of the world's oceans is still, in many areas, terra incognita. It is unmapped, unexplored, and full of surprises. The discovery also raises a question that echoes through every part of this documentary. How much of human history, how much of the genuine story of what our ancestors did and built and achieved, is currently sitting beneath the ocean, inaccessible to the standard tools of archaeology, waiting to be found by the underwater surveys and remote sensing technologies that are only now becoming sophisticated enough to look for it? To begin to answer that question, we need to understand the scale of what has been lost to rising sea levels. We tend to think of the ocean as a fixed thing. The coastlines on our maps feel permanent. The division between land and sea feels like a basic feature of the world, but this feeling of permanence is an illusion. Over the timescales relevant to human history, the boundaries between land and sea have shifted dramatically, repeatedly, and in many cases catastrophically from the perspective of the human populations who lived through those shifts. The last ice age ended, its great ice sheets began their final retreat approximately 20,000 years ago. Sea levels at that time were at their lowest point, roughly 120 to 130 meters below their current level. Over the next 14,000 years, as the ice melted, those seas rose. They rose at varying rates, sometimes gradually, sometimes in dramatic pulses as massive ice sheets collapsed all at once. There were periods when the rate of sea level rise exceeded 3 to 4 meters per century, fast enough that within a single human lifetime, the shoreline could shift by many kilometers. Communities that had been established on fertile coastal plains found themselves watching the ocean advance toward them, year by year, generation by generation. The total land area lost to the rising seas since the peak of the Ice Age is almost incomprehensible in its scale. Current estimates suggest that the global sea level rise since that time has submerged an area of continental shelf, roughly equivalent to the combined land area of Europe and China. That is an enormous amount of real estate. And it was not uninhabited real estate. Coastal environments, as we have already noted, are among the most productive and attractive environments for human settlement. They provide reliable food from the sea, access to fresh water from rivers and springs, moderate climates, and easy transportation along the coast and up rivers. Throughout human history and prehistory, the coast has been one of the preferred locations for human settlement. And a significant portion of those ancient coastal settlements, perhaps the majority, particularly the ones that were most densely populated and most strategically located at river mouths and natural harbors, are now underwater. Let us look at some specific examples of what this means. The Persian Gulf, today a relatively shallow body of water averaging about 35 meters in depth, was almost entirely dry land at the peak of the last ice age. It was a great river valley, traversed by a powerful river fed by the Tigris, Euphrates, Karun, and other rivers draining from the surrounding highlands. The climate of this valley during the late Ice Age and the subsequent warming period was not the harsh desert climate of today's Middle East, but something closer to a savanna, seasonal grasslands, woodlands, wetlands, and fertile floodplains supporting a rich diversity of plant and animal life. It would have been an extraordinarily attractive environment for human settlement, and the genetic and archaeological evidence suggests that it was indeed heavily populated during the period before it flooded, that the submerged lands of the Persian Gulf were home to significant human populations for thousands of years before the rising sea covered them. The flooding of the Persian Gulf happened in stages between approximately 14,000 and 8,000 years ago. First, the southern end flooded as the Strait of Hormuz deepened and the Indian Ocean began to pour in. Then the flooding progressed northward as sea levels continued to rise. By approximately 8,000 years ago, the Persian Gulf had taken roughly its current shape, though it continued to change at its margins as sea levels made their final adjustments. The human populations who had lived in the Gulf Valley were displaced, pushed northward and onto the flanking plains, the Mesopotamian lowlands that would later become the cradle of the world's first documented civilizations. Is it possible that the stories of that flooding, the sudden, traumatic inundation of a fertile homeland, survived in cultural memory? Is it possible that the Mesopotamian flood myths, which describe a great inundation that destroyed a previous world, are in some way a cultural echo of the flooding of the Persian Gulf Valley? These are questions that scholars have debated seriously and thoughtfully, and while no definitive answer has been established, the coincidence of timing and geography is striking enough that it cannot be dismissed. Similar stories can be told about virtually every coastline on Earth. The North Sea between Britain and continental Europe was dry land at the peak of the Ice Age, a vast, flat, fertile plain that archaeologists have named Doggerland, after the Dogger Bank that now lies at the center of the North Sea. Doggerland was home to thriving populations of Mesolithic hunter-gatherers for thousands of years. It was gradually flooded as sea levels rose, with the final catastrophic inundation occurring approximately 8,200 years ago when a massive submarine landslide off the coast of Norway, known as the Storegga Slide, generated a tsunami that swept across the low-lying plains and completed the separation of Britain from the European mainland. The people of Doggerland were not mythical. They were real human beings who left behind their tools, their weapons, their food remains, and their dead, all of which are now scattered across the floor of the North Sea, recoverable only by the trawl nets of fishing vessels and the occasional targeted archaeological survey. In Southeast Asia, the vast continental shelf known as the Sunda Shelf connected the islands of Sumatra, Java, Borneo, and the Malay Peninsula into a single landmass at the peak of the Ice Age, a landmass sometimes called Sundaland. This was a vast, tropical, heavily forested landmass with a complex river system and a climate that would have supported large human populations. It was gradually submerged as sea levels rose, reaching its current configuration approximately 10,000 years ago. The human populations of Sundaland, the ancestors of the modern peoples of Southeast Asia, were displaced, pushed onto the remaining islands and coastlines, and their coastal settlements and the evidence of their long habitation of those lowland environments now lie beneath the South China Sea and the Java Sea. The pattern repeats everywhere you look. The rising of the seas at the end of the Ice Age was the greatest geographical transformation of the human-inhabited world in the entire span of human history. It reshaped coastlines, drowned river valleys, separated islands from mainlands, and eliminated entire regions of human settlement. And because it happened so long ago, thousands of years before the development of writing, the evidence for what was lost has survived primarily in the underwater sediments of the world's continental shelves, waiting to be discovered, and discovering it is becoming more possible every year. The technology for underwater exploration has advanced at a remarkable pace over the past 3 decades, and the pace of advancement is, if anything, accelerating. The tools that are now available to marine archaeologists and deep-sea explorers would have seemed like science fiction to earlier generations of underwater researchers. Multibeam sonar, as we have already mentioned, allows the creation of detailed 3-dimensional maps of the seafloor at resolutions that can reveal features as small as a meter or 2 across over areas of many square kilometers. Sub-bottom profilers use acoustic signals to penetrate the sediment layer and image structures buried beneath the seafloor surface, allowing the detection of archaeological remains that are covered by centuries or millennia of sediment accumulation. Remotely operated vehicles, ROVs, equipped with high-definition cameras, manipulator arms, and scientific instruments can explore depths of several thousand meters, collecting visual data and physical samples without putting human divers at risk. Autonomous underwater vehicles, AUVs, can be programmed to follow survey patterns across large areas of seafloor, gathering data continuously and returning it for analysis. An advanced DNA sequencing technology applied to sediment core samples can detect the genetic signatures of organisms and potentially of human populations that existed in a given location thousands of years ago. The application of these technologies to the problem of submerged archaeological sites is still relatively new. Underwater archaeology as a discipline dates back only to the middle of the 20th century, and for most of its history, it has been constrained by the limitations of diving technology, limiting serious archaeological work to relatively shallow depths accessible to human divers. The advent of ROV and AUV technology has opened up the deep ocean to archaeological investigation for the first time, and the early results have been extraordinary. One of the most striking examples of what these technologies can find in the deep ocean is the collection of ancient shipwrecks discovered in the Black Sea. The Black Sea is a remarkable and unusual body of water in its own right, and we will return to it in more detail later. But for now, let us note that the discovery of over 40 exceptionally well-preserved ancient shipwrecks at depths of several hundred meters in the Black Sea, including vessels with intact hulls, rigging, and cargo that date back more than 2,000 years, demonstrated beyond any doubt that the deep ocean can preserve archaeological evidence in extraordinary condition over very long periods of time. The Black Sea discoveries were a proof of concept. The deep sea contains ancient ships, and modern technology can find and document them. The question that naturally follows from this is, how old can the ships be? The Black Sea examples date back to the ancient Greek and Byzantine periods, 2,000 to 2,500 years old. But the preservation conditions in the Black Sea's deep anoxic waters, conditions that are in some ways comparable to the brine pool environments of the Red Sea, have maintained those vessels in a state that would allow them to be studied centuries from now. If ships from 2,000 years ago can be preserved in these conditions, what about ships from 10,000 years ago, from 20,000 years ago, from 30,000 years ago? The theoretical answer is, yes, preservation over those timescales is physically possible, given the right conditions. The practical answer is, we don't know yet because we haven't looked systematically enough. The surveys of the Red Sea Rift Zone that produced the controversial dating results were not primarily archaeological surveys. They were geological and oceanographic surveys that stumbled upon archaeological evidence by accident. A systematic, targeted archaeological survey of the deep Red Sea with the specific goal of finding and characterizing organic material from the relevant time period has not yet been conducted. That is one of the most important things to understand about this field of research. We are in the very early stages of exploring a vast, largely unknown territory. The deep ocean covers about 2/3 of the Earth's surface, and the fraction of it that has been systematically surveyed at high resolution is tiny, estimated at less than 20% of the total seafloor for sonar mapping, and far less than that for direct visual inspection. The deep ocean, in terms of human exploration and understanding, is comparable to the surface of the Moon or Mars before the space age, a known entity that has nevertheless never been properly looked at. Let us now turn to one of the most remarkable features of the African continent, a feature that has been the subject of intense debate and speculation for decades, and that lies not beneath the sea but in the middle of the Sahara Desert. Because one of the greatest underwater mysteries is connected to a place that is, at this moment, one of the driest places on Earth. We are talking about the Richat structure, the Eye of the Sahara, and its contested connection to the greatest underwater legend of all time, the lost city of Atlantis. The Richat structure is located in the western Sahara, in what is today the country of Mauritania. It is a massive circular geological formation approximately 50 kilometers in diameter, so large that it can be seen clearly from space, and is used by astronauts aboard the International Space Station as a visual landmark for navigation. From the ground, it is a series of concentric ridges and valleys, eroded by millennia of wind and weather into a series of rings that, from above, look uncannily like a target or a bull's eye drawn on the surface of the desert. The scientific explanation for the Richat structure has evolved over the decades. Early researchers suggested it was the result of a meteorite impact. The circular shape seemed consistent with an impact crater, but detailed geological analysis showed that there was no evidence for the kind of shock metamorphism or melt rock that invariably accompany large meteorite impacts. The current scientific consensus is that the Richat structure is a geologically uplifted dome, a place where the rock layers beneath the surface have been pushed upward, and where subsequent erosion has carved through the uplifted dome to expose concentric rings of different rock types, each ring corresponding to a different geological layer. This is a known geological process, and the Richat structure is one of the most spectacular examples of it on Earth. But in recent years, a new theory has gained significant traction in alternative history circles and has even attracted the attention of some mainstream researchers. The theory that the Richat structure is the site of the legendary city of Atlantis, as described by the ancient Greek philosopher Plato in his dialogues Timaeus and Critias. Plato's account of Atlantis, written approximately 360 BCE, describes a great island civilization located beyond the Pillars of Hercules, that is, beyond the Strait of Gibraltar in the Atlantic Ocean. According to Plato, Atlantis was a powerful naval empire that had conquered much of the Mediterranean world before being defeated by the ancient Athenians and subsequently destroyed by the gods, sinking beneath the ocean in a single day and night of catastrophic earthquakes and floods. Plato gives various details about the geography of Atlantis that have been the subject of intense scholarly scrutiny for more than 2 millennia. He describes the city itself as having been built on a circular plain surrounded by concentric rings of land and water, alternating bands of land and sea surrounding a central island where the great palace of the Atlantean kings stood. Concentric rings, a circular structure, located somewhere in the general direction of the Atlantic Ocean from the Mediterranean. The physical similarity between Plato's description of the geography of Atlantis and the appearance of the Richat structure is striking enough that it has driven serious researchers to examine whether the Saharan formation might indeed be the historical basis for the Plato legend. The proponents of the Richat-Atlantis connection make several specific arguments. The dimensions of the Richat structure, approximately 50 kilometers in diameter, are consistent with Plato's description of Atlantis when his measurements, given in the ancient Greek unit of stads, are converted to modern measurements, at least approximately. The location of the Richat structure in the western part of Africa is broadly consistent with Plato's placement of Atlantis beyond the Pillars of Hercules. At the time Plato was writing, the Pillars of Hercules marked the western boundary of the known Mediterranean world, and the Sahara Desert west of those pillars was only vaguely known to the Greeks. The concentric ring structure of the Richat formation matches, at least in general outline, Plato's description of the concentric rings of land and water surrounding the Atlantean city, and here is where the underwater connection becomes critical. The Sahara Desert today is one of the driest places on Earth, but it was not always so. Geological and paleoclimate evidence shows clearly that during the period known as the African Humid Period, or the Green Sahara, a period that lasted from approximately 11,000 to 5,000 years ago, the Sahara was a very different environment. Monsoon rains, driven by changes in the Earth's axial tilt and orbital parameters, penetrated deep into what is now the desert interior, creating a landscape of grasslands, woodlands, rivers, lakes, and wetlands. The Sahara during this period was home to substantial populations of humans and large animals. We know this from the rock art that covers cliffs and rock shelters across the Saharan interior, depicting hippos, crocodiles, cattle, giraffes, and the people who hunted them in a landscape that looks nothing like the desert of today. If the Richat structure was inhabited during the Green Sahara period, and the environmental conditions of that period suggest it certainly could have been, then it would have been surrounded by a very different landscape than today's bare rock and sand. There is geological evidence suggesting that the lower-lying areas within the concentric ring structure of the Richat were occupied by a lake or series of lakes during wetter periods. If those lakes were present during the period of human habitation, the Richat structure would have had exactly the combination of features Plato describes: a circular landform surrounded by water, located in a fertile region with access to agricultural land, and the Atlantic Ocean, the body of water that Plato says ultimately swallowed Atlantis, is not that far away. The Richat structure is located only about 450 kilometers from the Atlantic coast of Mauritania. The Atlantis-Richat theory, while not accepted by mainstream archaeologists, is not a fringe idea in the way that some alternative history theories are. It is based on a specific, detailed comparison between a real geographical feature and an ancient text. It makes specific, testable predictions. If the Richat structure was indeed the site of a significant ancient settlement during the Green Sahara period, there should be archaeological evidence of that settlement in the form of foundations, artifacts, soil chemistry changes, and other traces of human occupation. Finding or failing to find such evidence would either support or refute the theory. That kind of testability is the hallmark of a scientific hypothesis rather than mere speculation. And here is the intriguing part. While extensive archaeological surveys of the Richat structure have not been conducted, preliminary investigations have found evidence of human habitation in the area during the relevant period. Stone tools, campfire remains, and the bones of animals that could not survive in today's desert conditions have been found in and around the formation. This is not proof of a great civilization. It is evidence of the kind of human presence you would expect in a well-watered environment during the Green Sahara period. But it does confirm that humans were there, and it raises the question of what a more detailed and systematic archaeological investigation might find. But we have been ranging widely across the land. Let us return to the water, because the most extraordinary evidence for lost human history lies beneath the waves. And one of the most compelling pieces of that evidence lies not in the Atlantic or the Red Sea, but in the Pacific Ocean off the coast of Japan at a place called Yonaguni. The Yonaguni Monument, sometimes called the Japanese Atlantis, or simply the Monument, is a massive underwater rock formation lying just offshore from the island of Yonaguni, the westernmost island in the Ryukyu chain that stretches between Japan and Taiwan. It was first noticed by a scuba diver named Kihachiro Aratake in 1986, who encountered what he initially took to be a natural rock formation, but which, on closer examination, seemed too geometrically regular to be entirely the product of nature. He reported his discovery, and over the following years it attracted the attention of both professional scientists and the wider diving community. The Yonaguni Monument is a large, roughly rectangular formation of sandstone and mudstone lying at depths of between 1 and 30 meters below the surface. It consists of a series of terraced platforms, steps, ramps, pillars, and other features that are arranged in a way that gives the overall structure a strikingly architectural appearance. The main terrace is approximately 250 meters long, 150 meters wide, and stands about 27 meters tall above the surrounding seafloor, roughly the height of a 10-story building. Its sides are mostly vertical or near vertical, and its top surface is relatively flat. A series of large step-like features descend from the main terrace to the seafloor, with individual steps up to a meter high and several meters wide. There are what appear to be roads or pathways on the surface, twin rock pillars that look like columns, a feature that has been compared to a monument or a stage, and several smaller subsidiary structures in the surrounding area. The central question about the Yonaguni Monument, the question that has been debated by scientists for nearly 4 decades, is whether it is a natural geological formation or the work of human hands. And unlike some of the other cases we have discussed, this debate has generated genuine scientific literature on both sides, with serious researchers carefully examining the evidence and reaching different conclusions. The case for natural origin centers on the geology of the formation. Yonaguni sits in a geologically active area where the rocks are predominantly fine-grained sandstones and mudstones that have a strong tendency to fracture along regular planes, both horizontal and vertical. This property of the rock, combined with millions of years of geological uplift, wave erosion, and the effects of repeated seismic activity in one of the world's most seismically active regions, could theoretically produce the terraced, stepped appearance of the monument without any human intervention. Geologists who favor the natural explanation point to the fact that similar, if smaller and less dramatic, terraced rock formations can be found in other areas of similar geology around the world. The case for human construction, or at minimum, human modification of an existing natural formation, centers on several specific features that seem difficult to explain purely by natural processes. The most compelling of these is the overall organization of the structure. The fact that the terraced steps, the flat surfaces, the right-angle corners, and the other regular features all occur together in a single large formation, arranged in a pattern that creates the overall appearance of a coherent architectural plan. Natural erosion tends to be random and irregular. It removes material from rocks according to their differential resistance to weathering, producing formations that, while sometimes geometrically striking, are typically inconsistent and disorganized when examined in detail. The Yonaguni Monument, by contrast, has a degree of overall organization that is unusual for a natural formation of this scale. There are also specific features that are particularly difficult to explain naturally. A channel cut into the rock, regular, with parallel walls and a flat bottom, that runs for a considerable distance before turning at a right angle, is not the kind of feature that erosion naturally produces. A series of circular holes drilled into a flat rock surface in what appears to be a regular pattern is difficult to attribute to any known natural process. And a feature that has been interpreted as a stone pillar standing upright on the terraced surface would require an extremely unlikely sequence of erosional events to have been created naturally. The most relevant piece of information for our purposes is the dating of the monument. Yonaguni lies in the East China Sea, on the edge of the continental shelf of the Asian continent. During the peak of the last ice age, when sea levels were 120 to 130 meters lower than today, the area around Yonaguni was not underwater. It was dry land, part of the broad continental shelf that then connected the Asian mainland to what are now the island chains of the Western Pacific. The monument itself, sitting at its current depth of between 1 and 30 meters, would have been above water, accessible to human builders, until sea levels rose to submerge it. Based on the current understanding of sea level change in the region, the Yonaguni Monument would have been above water until approximately 8,000 to 10,000 years ago, when rising seas finally submerged it. This means that if the monument is a human-made structure, it was built by people who lived more than 8,000 years ago, before the civilization that eventually became the cultures of Japan, China, and the rest of East Asia had developed in any recognizable form. It would have been built by people of the Jaman culture, the earliest known inhabitants of the Japanese islands, or by an even earlier population that preceded them. And while the Jaman are known for their sophisticated pottery and their complex hunter-gatherer lifestyle, they are not generally credited with the capability of constructing large monumental stone structures. Unless, of course, the Yonaguni Monument makes us revise our understanding of what the Jaman or their predecessors were capable of. Unless it is evidence, like so many of the other discoveries we have been discussing, that the story of early human capability is much more complex and much more surprising than we have been led to believe. Complexity and surprise, Those are the two words that keep coming up as we examine the evidence from beneath the world's oceans. The story of human prehistory is not the simple linear progress from primitive cave dwellers to sophisticated civilizations that is often presented in textbooks. It is a vastly more complex, more nonlinear, more surprising story, one in which sophisticated human behaviors appear earlier than expected, in which long periods of development are separated by catastrophic disruptions, and in which much of the evidence has been hidden by the simple accident of rising sea levels. Consider the sea cucumber, one of the ocean's most extraordinary and bizarre residents. This animal, technically a marine invertebrate related to sea stars and sea urchins, lives on the seafloor of oceans around the world, from the shallow coastal waters to the very deepest parts of the abyss. At first glance, it is not an impressive creature. It looks like a lumpy, leathery sausage, lying on the seafloor and seemingly doing very little. But the sea cucumber is, in its own way, a marvel of evolutionary engineering. When threatened by a predator, some species of sea cucumber employ a defense strategy that is simultaneously revolting and astonishing. They expel their own internal organs through their body wall, essentially turning themselves inside out to distract the predator, and then regenerate those organs over the following weeks. Others can liquefy their body tissues and pour themselves through gaps in rock or coral, solidifying on the other side. Some species produce toxic compounds so potent that a single individual contains enough toxin to kill large numbers of fish in a confined space. And the sea cucumber plays a crucial ecological role in the deep sea ecosystem, consuming sediment and organic matter, processing it through their digestive systems, and releasing the nutrients back into the water column in a form that other organisms can use. The sea cucumber reminds us that evolution, biological evolution and cultural evolution alike, does not always proceed by the routes we expect. The path from simple to complex is not always a straight line. Sometimes the most remarkable capabilities emerge in the most unexpected places, in forms that we do not immediately recognize as sophisticated because they are so different from what we are used to seeing. The same might be said of the ancient humans whose evidence we have been examining. We look for sophistication in the forms we recognize: cities with regular streets, writing systems, monumental temples, clear political organization. And when we do not find those things, we conclude that sophistication was absent, but sophistication can take many forms. The ability to navigate open ocean, to build watercraft capable of surviving the conditions of the Red Sea, to organize groups of people for collective technological projects, these are forms of sophistication. They do not require writing or monumental architecture. They require knowledge, accumulated over generations, transmitted through careful teaching and practice. They require social organization sufficient to coordinate the efforts of many individuals. They require a deep understanding of natural materials and how to work them. The people who 30,500 years ago may have been operating watercraft on the Red Sea were fully modern humans. Their brains were identical to ours. Their capacity for learning, for abstraction, for planning and problem solving was in every way the equal of any person alive today. What they lacked was not intelligence or capability, it was accumulated knowledge. They did not have the benefit of 10,000 years of written history to draw on, but in the domains where they did have accumulated knowledge, navigation, boat building, hunting, gathering, reading the natural world, they were specialists of extraordinary depth. And perhaps in some places and at some times that accumulated knowledge reached levels that we have not yet given them credit for. Let us pause for a moment to look at a creature that in its own way illustrates the extraordinary capabilities that can be packed into an apparently simple organism. The mantis shrimp, the dazzling, ferocious, and deeply weird crustacean that lives in tropical ocean environments around the world, is an animal that has been pushing the boundaries of what we thought possible in biological vision for decades. The mantis shrimp has 16 different types of photoreceptors in its eyes. For comparison, humans have 3. We see the world in terms of the relative intensities of red, green, and blue light, and we call the result full color vision. The mantis shrimp, with its 16 photoreceptor types, can detect wavelengths of light ranging from deep ultraviolet to far infrared, a range of the electromagnetic spectrum that is completely invisible to human eyes. It can detect the polarization of light, which allows it to see features of objects, surfaces, materials, biological tissues that are completely transparent to our perception. It can detect circularly polarized light, a property of light that no other known animal can sense. The visual world of the mantis shrimp is so vastly richer than our own that it is essentially impossible for us to imagine what it is like to see through those eyes. But here is the fascinating twist. When scientists studied how the mantis shrimp actually uses all this visual information, they discovered that it does not use it the way we use our color vision. We combine the input from our 3 photoreceptor types in a complex, comparative way that allows us to distinguish millions of different colors. The mantis shrimp, by contrast, processes its 16 photoreceptor inputs in a much simpler way, essentially checking whether the light it is seeing matches specific templates, rather than comparing it in a complex comparative analysis. This gives the mantis shrimp a visual system that is extraordinarily fast at recognizing specific things, predators, prey, potential mates, with the right color signals, but is actually less capable than human vision at making fine discriminations between similar colors. The mantis shrimp has evolved a vision system optimized for its specific needs in its specific environment, not a general-purpose visual processor. The lesson of the mantis shrimp is that capability is always contextual. A system that appears primitive or simple by one measure may be extraordinarily sophisticated by another. The 16 photoreceptor types of the mantis shrimp are not, in themselves, a sign of superior visual processing. They are a sign of a different kind of visual processing, adapted to a different set of environmental challenges. In the same way, the societies of early modern humans were not primitive in any absolute sense. They were adapted to their specific circumstances, their specific environments, their specific challenges. And within those adaptations, capabilities could develop that we might not recognize as sophisticated because they are so different from the kinds of sophistication we associate with complex civilization. We have been talking about what lies beneath the surface of the ocean. But before we go deeper, before we follow the evidence further into the dark water, let us step back and consider the broader story that all of these individual discoveries are telling us. What is the pattern? What is the overarching narrative that emerges when you look at the brine pools of the Red Sea, the underwater structures off Cuba, the Eye of the Sahara, the Yonaguni Monument, and all the other anomalies we have been examining? The pattern is this: the timeline of complex human behavior and potentially of complex human civilization extends much further back than the conventional narrative acknowledges. Not by a few hundred years, not by a few thousand years, but potentially by tens of thousands of years. The evidence is incomplete, contested, and often difficult to interpret definitively. But it is real evidence, physical evidence, found in specific locations and dated by scientific methods. It cannot be dismissed simply because it is inconvenient for the current consensus. And there is a reason why the evidence is incomplete. There is a reason why we have not, until now, been able to see this pattern clearly. The reason is the ocean. The ocean has been rising for the past 20,000 years, slowly and steadily swallowing the coastlines where, in all probability, the most sophisticated and densely populated human communities of the Ice Age were living. It has buried the evidence of those communities under tens of meters of seawater and sediment. It has hidden the most important chapters of human prehistory beneath a liquid archive that we are only now, with the development of deep-sea exploration technology, beginning to open. Think about what this means. The sites that we currently rely on for our understanding of prehistoric humanity are almost exclusively inland sites, cave systems, open-air campsites in continental interiors, rock shelters above the ancient sea level. These are the sites that have survived on dry land, accessible to traditional archaeology. but they may be deeply unrepresentative of where prehistoric humans actually spent most of their time and developed most of their culture. The coast and everything that happened there is gone, submerged, waiting, and in the deep water, in the cold, dark, oxygen-poor environments where normal decomposition cannot occur, the evidence of what happened on those ancient coasts is preserved. It is waiting in the sediments of the continental shelf. It is lying in the brine pools of the Red Sea. It is scattered across the floor of the Persian Gulf. It is sitting on the terraced slopes of the Sunda Shelf. It is out there in the dark, patient and silent, holding the secrets of what our ancestors really were and what they really achieved. Now, let us follow one more thread before we conclude this first part of our journey. Let us look at one more body of water that holds extraordinary secrets, and that has recently produced some of the most dramatic and unambiguous evidence for the kind of deep-time human maritime activity we have been discussing throughout this documentary. The Black Sea is, by any measure, one of the most unusual bodies of water on the planet. It is a nearly landlocked sea, connected to the Mediterranean only through the narrow, shallow straits of the Bosphorus and the Dardanelles. This restricted connection to the world ocean has given the Black Sea a unique and, from a scientific perspective, remarkable chemistry. The surface waters of the Black Sea are relatively fresh, fed by numerous large rivers, the Danube, the Dnieper, the Don, and others, that carry enormous volumes of fresh water from the European interior. This fresh surface layer is lighter than salt water and floats on top of the denser, saltier water that enters from the Mediterranean through the bottom of the Bosphorus Strait. The two layers do not mix, a condition known as meramixis, and the deep water of the Black Sea has been essentially isolated from the surface for thousands of years. The consequence of this stratification is extraordinary. The deep water of the Black Sea, below approximately 200 meters, is completely devoid of oxygen. It is anoxic. It is filled instead with hydrogen sulfide, a toxic gas produced by sulfate-reducing bacteria that thrive in the oxygen-free environment. In this deep, dark, poisonous water, the normal processes of decomposition cannot occur because the bacteria and other organisms that normally break down organic matter require oxygen to function. Anything that sinks into the deep Black Sea is preserved, chemically frozen in time, maintained in a state of exceptional condition for as long as the anoxic conditions persist. Scientists have known about the unusual chemistry of the Black Sea for decades. But the archaeological implications of that chemistry were not fully appreciated until a series of deep-sea expeditions beginning in the early 2000s began systematically surveying the Black Sea floor using ROVs and sonar. What they found was beyond anything they had anticipated. In 2017, a team of researchers operating from the research vessel Strill Explorer, using an ROV to survey the deep anoxic waters of the Black Sea, discovered a collection of ancient shipwrecks in a state of preservation that is essentially without parallel in the history of underwater archaeology. More than 60 shipwrecks were eventually identified and documented, ranging in date from approximately 400 BCE to the medieval period, covering more than 2,000 years of maritime history. The wrecks include ancient Greek trading vessels, Byzantine ships, and Ottoman-era craft, and they are preserved in a condition that can only be described as astounding. The hulls are intact. The masts are still standing, tilted at an angle against the seafloor. The rigging is still in place, ropes, lines, and tackle still threaded through blocks and cleats, just as the sailors had arranged them on the day the ship went down. Carved decorative elements on the stern and prow are still crisp and detailed, as if the ship had sunk last year rather than centuries or millennia ago. The holds of some of the wrecks still contain their cargo, amphoras, pottery, trade goods, stacked as they were originally loaded. These Black Sea wrecks are a direct demonstration of what the anoxic deep ocean can preserve. They are proof of concept for the idea that the deep sea holds archaeological evidence in extraordinary condition over long periods of time, and they raise, with stark and unavoidable clarity, the question of what else might be down there. The oldest of the Black Sea wrecks so far found dates to approximately 2,400 years ago, the ancient Greek period. But the Black Sea has been connected to the Mediterranean, and maritime trade has been conducted on its waters for much longer than that. If anoxic conditions exist at depths below 200 meters, and if ships have been sinking in the Black Sea for thousands of years, then there should be wrecks much older than the oldest currently discovered, stretching back perhaps 5,000 or 6,000 years, to the very dawn of organized maritime trade in the eastern Mediterranean and Black Sea region. Those wrecks would be even better preserved than the ones already found, because they have been lying in the anoxic water for even longer without disturbance. And before those Bronze Age wrecks, there might be even older vessels, boats and rafts used by the Neolithic farmers and fishers who first began to navigate the Black Sea in the millennia after it took its current form. The Black Sea, like the Red Sea, like the Persian Gulf, like so many other bodies of water around the world, is an archive. It is a library of human maritime history, and we have barely cracked the cover. Let us now consider the pigs. You might be wondering why a documentary about underwater archaeology and prehistoric civilization is going to talk about pigs. Bear with us, because the intelligence of pigs turns out to be relevant in a way that illuminates something important about how we assess the capabilities of other minds. Pigs are among the most intelligent non-human animals on Earth. Studies have shown that domestic pigs can be trained to play video games using joystick controls with their snouts, a task that requires understanding the abstract relationship between moving the joystick and the movement of a cursor on a screen, which is a form of symbolic reasoning. Pigs have demonstrated self-recognition in mirrors, one of the classic tests for self-awareness, at a level comparable to chimpanzees and dolphins. They form complex social relationships, demonstrate empathy, have excellent long-term memories, and show clear evidence of emotional lives that include excitement, boredom, depression, and joy. In cognitive tests designed to measure problem-solving ability, pigs consistently outperform dogs, which most people consider to be highly intelligent animals. Yet our cultural perception of pigs is that they are dirty, simple, greedy animals, useful for food, but not otherwise remarkable. This perception is entirely wrong. It is based on superficial observation of animals kept in conditions that are profoundly unsuitable for their intelligence and social needs, and it has led us to dramatically underestimate the inner lives and capabilities of these animals for centuries. The parallel to our assessment of prehistoric humans should be obvious. We look at the limited material evidence left by our ancient ancestors, stone tools, cave paintings, scattered middens, and we conclude that they were simple, primitive, and limited in their capabilities. We see the surface and conclude we understand the depths. But just as the pig's intelligence is not visible in its outward appearance, the capabilities of early modern humans may not be fully visible in the artifacts that have survived the ravages of time and submersion. The absence of evidence is not evidence of absence, particularly when we know, as we do, that the environments where most of the evidence would have been found are now submerged beneath tens of meters of ocean water. The people who were alive 30,500 years ago were as intelligent as we are. That is not a speculation. It is a fact established by extensive genetic and paleoanthropological research. Their brains had the same size, the same architecture, the same cognitive capabilities as modern human brains. They were fully capable of the kind of abstract thought, the kind of knowledge accumulation, the kind of social coordination, and the kind of technical problem solving that boat building and ocean navigation require. The only question is whether, in specific places and times, they had accumulated the specific knowledge and social organization needed to put those capabilities to use in maritime technology. And the evidence, fragmentary, contested, but real, suggests that in some places, at some times, they had. We have covered an enormous amount of ground in this first part of our journey, from the brine pools of the Red Sea to the underwater structures off Cuba, from the Eye of the Sahara to the Yonaguni Monument, from the Black Sea shipwrecks to the broader question of what the world looked like during the Ice Age and what we may have missed in the sediments beneath the world's oceans. As we prepare to go deeper in the second part of this documentary, let us take stock of what we have established. We have established that the conditions for extraordinary preservation of ancient materials exist in the deep ocean, particularly in anoxic environments like the deep Black Sea and the brine pools of the Red Sea. We have established that sea levels during the Ice Age were dramatically lower than today, low enough that vast areas of what is now the continental shelf were dry land, and that any coastal settlements from that period are now underwater. We have established that humans were crossing open ocean at least 65,000 years ago, and that the Red Sea region was a critical corridor for early human migration. We have established that the dating of organic materials found in the Red Sea Rift Zone has produced results suggesting the presence of worked materials, potentially from watercraft, at approximately 30,500 years ago. We have established that anomalous underwater structures exist off the coasts of Cuba and Japan that have not been satisfactorily explained either as natural formations or as human-made structures, and that they could represent the submerged remains of ancient coastal civilizations. We have established that the Eye of the Sahara presents a remarkable correspondence with Plato's description of Atlantis, and that the Sahara was once a fertile, well-watered environment capable of supporting large human populations. And we have established, most fundamentally, that the story of human prehistory is far less settled than we often assume, that the conventional narrative is based on an inherently biased sample of the evidence, skewed toward inland sites and away from the coastal environments where much of the most important human cultural development may have occurred, and that the rising of the seas at the end of the Ice Age hid the most important chapters of that story beneath the ocean. In the second part of this documentary, we will go deeper. We will look at the specific evidence for ancient maritime technology in more detail. We will examine the geology of the Red Sea and what it tells us about what was possible in that ancient ocean. We will explore more of the world's mysterious underwater structures and what they reveal about the range of possibilities for early human achievement. We will look at the patterns of global mythology and oral tradition that seem to encode memories of a lost antediluvian world, a world that was real, that existed, and that was drowned by the rising seas. And we will try to assemble all of this evidence, the geological, the archaeological, the biological, the mythological, into a coherent picture of what the human story on this planet actually looks like when you account for the chapters that have been hidden beneath the waves. Because the ocean holds secrets that are beginning at last to surface, and when they do, when the full evidence of what our ancestors were doing and building and achieving in the distant past is finally assembled, the history of humanity will have to be rewritten, not at the margins, not in small details, but fundamentally at its core. The story is older than we thought. The people were more capable than we gave them credit for. And the world they lived in, the world that was drowned, was more complex, more diverse, and more remarkable than anything our current history books acknowledge. Stay with us, because in the second part we go even deeper into the ancient depths. The secrets are waiting. The ocean remembers. There is a moment that every deep-sea explorer describes in almost identical terms, regardless of where they come from, what language they speak, or what specific ocean they are descending into. It is the moment when the submersible or the remotely operated vehicle passes below the reach of the last photon of sunlight, the moment when the blue dims to black, when the world above becomes irrelevant, and when the only reality is the small bubble of artificial light moving through an infinite darkness. In that moment, the explorer feels two things simultaneously: an almost overwhelming sense of smallness, of human insignificance in the face of the vast, ancient, indifferent deep, and an equally powerful sense of anticipation. Because somewhere in that darkness, something is waiting, something that has been waiting for a very long time, and you are the first human being who has ever come close enough to see it. Welcome back. In the first part of this documentary, we laid the foundation. We explored the extraordinary preservative environments of the deep ocean, the brine pools of the Red Sea, the anoxic depths of the Black Sea, and we established that these environments are capable of maintaining ancient organic materials in exceptional condition across timescales that challenge our conventional understanding of prehistory. We examined the evidence for anomalous underwater structures off the coasts of Cuba and Japan. We looked at the Eye of the Sahara and its tantalizing correspondence with Plato's Atlantis, and we confronted the central challenge of underwater archaeology, that the most important chapters of early human coastal history are buried beneath tens of meters of ocean water, the legacy of sea levels that have risen dramatically since the end of the last ice age. Now we go deeper. In this second part, we are going to examine the evidence more rigorously. We are going to look at what the specific findings in the Red Sea Rift Zone actually tell us about the people who may have been operating watercraft in that ancient sea 30,000 years ago. We are going to explore additional underwater mysteries from around the world, the Mediterranean circles, the Baltic anomalies, the submerged forests that border so many of the world's continental coastlines. We are going to look at what the world's mythological traditions tell us about a lost antediluvian world, and consider whether those traditions encode genuine historical memory. And we are going to try to answer the question that has been implicit in everything we have discussed. What would it mean for our understanding of ourselves and our history if the evidence for a 30,500-year-old seafaring culture in the Red Sea turns out to be exactly what it appears to be? The answer to that question is more important than you might think, and it points toward a future of underwater exploration and discovery that has the potential to be the most transformative scientific enterprise of the 21st century. Let us begin. To understand the full significance of what may have been found in the Red Sea, we need to understand what boat building actually requires. Not in the modern sense, not the computer-aided design and industrial manufacturing of contemporary shipbuilding, but in the fundamental, essential sense. What does it take to look at a body of water and decide to build something that will carry you across it? What knowledge, what skills, what social organization does that require? At its most basic level, boat building requires the observation that certain materials float. Wood floats, bundles of reeds float, animal skins filled with air float. This is not a subtle discovery. It is something that any observant person living near water would notice repeatedly over the course of a lifetime. The step from observing that wood floats to deliberately using floating wood to support a person in water is a small cognitive step, and there is every reason to believe that early modern humans made that step tens of thousands of years ago. The next step from a simple raft of floating logs to a shaped vessel capable of navigating open water is significantly more complex, but it is a step that has been taken independently by human populations all around the world, in every environment where open water posed a barrier or an opportunity. The diversity of watercraft technologies developed by different human cultures is itself evidence of the fundamental human impulse to cross water. The canoes of the Pacific Islands, the reed boats of the Nile and Lake Titicaca, the coracles of Wales and Ireland, the kayaks of the Arctic, the outrigger canoes of Southeast Asia, the clinker-built longboats of the North Sea. Each of these traditions represents an independent development of boat-building technology, adapted to local materials and local conditions, and each of them demonstrates that the cognitive and technical requirements for building watercraft are well within the reach of pre-agricultural human societies. The key insight here is that boat-building does not require cities. It does not require writing. It does not require metal tools or agricultural surplus, or any of the other hallmarks of what we conventionally call civilization. It requires wood or other buoyant materials, cutting and shaping tools of sufficient quality to work those materials, fiber for lashing or rope, knowledge of water and weather accumulated over many generations, and a social organization capable of coordinating the effort of several people over the days or weeks required to build a vessel. All of these things were available to modern humans 30,500 years ago, Stone tools capable of shaping wood were in use for hundreds of thousands of years before that date. Plant fiber for rope was available in the Red Sea region. The cognitive capability to accumulate and transmit the knowledge of boat building was fully present in anatomically modern humans by at least 100,000 years ago. The social organization required a group of a few dozen people with a tradition of knowledge and a common purpose is the kind of social organization that characterized human groups throughout the Paleolithic. There is, in other words, no fundamental barrier to the existence of boat-building technology 30,500 years ago. The question is not whether it was possible, it clearly was, but whether the specific evidence found in the Red Sea Rift Zone reflects the reality of that possibility. Let us now look more carefully at the specific characteristics of the material found in the Red Sea Rift Zone that form the core of the claim about a 30,500-year-old fleet. We touched on this in the first part, but the details matter, and the details are worth examining carefully. The organic material recovered from the survey sites in the central Red Sea Rift Zone can be divided into three broad categories: worked wood, fiber cordage, and what appears to be a mineral sealant or caulking compound. Each of these categories tells a different part of the story, and together they paint a picture that is difficult to explain without reference to watercraft construction. The worked wood is the most immediately dramatic of the three. The fragments range in size from small chips and splinters to pieces measuring several tens of centimeters in their longest dimension. Some of these fragments are simply smooth, flat pieces of wood, the kind of surface that results from deliberate planing or scraping with a sharp tool, rather than natural fracture or erosion. Natural wood fractures tend to follow the grain of the wood, producing irregular splinter-like pieces with fibrous surfaces. The smooth, flat surfaces on some of the Red Sea fragments are inconsistent with natural fracture and consistent with deliberate shaping. More significant are the fragments that show evidence of joinery, the techniques used to connect pieces of wood together. In boat building, as in any wooden construction, connecting individual pieces of wood in a structurally sound way is one of the central technical challenges. Different cultures have developed different joinery techniques: mortise and tenon joints, lashing with fiber cordage, wooden pegs and dowels, various forms of interlocking joints. In the Red Sea material, several fragments show features consistent with specific joinery techniques. There are holes that appear to have been deliberately drilled or bored through the wood, consistent with the use of wooden pegs or dowels. There are grooves and channels cut into the surfaces of some pieces in ways consistent with lashing, the technique of binding pieces together with fiber cordage wrapped around or through specific features of the wood. And there are pieces that appear to have been shaped to fit together with other pieces, not perfectly, because the preservation is not perfect and the pieces have been separated, but with a degree of correspondence that suggests they were once part of the same structure. The fiber cordage is in some ways even more compelling than the wood. As we mentioned in the first part, fiber cordage, rope, is an artifact of deliberate human manufacture. It does not occur naturally. Plant fibers do not spontaneously twist themselves into rope. The cordage found in the Red Sea Rift Zone shows clear evidence of the basic rope-making technique. Individual plant fibers twisted together in one direction to form strands, then multiple strands twisted together in the opposite direction to form a rope. This two-stage twisting process, known as plying, is the fundamental principle of all rope-making technology, and it appears in the archaeological record in various forms going back at least 40,000 years, so its presence at a 30,500-year-old site is not, in itself, surprising. What is significant is its presence in association with the worked wood in the specific context of the Red Sea Rift Zone. The plant species from which the cordage was made has been identified through microscopic examination of the fiber structure. The fibers are consistent with a species of reed or marsh grass that grew in the coastal wetlands of the ancient Red Sea region during the relevant period, a species that is still found in the area today, though the wetland habitats it prefers are now much reduced in extent. This is important because it provides a provenance, a geographic and ecological origin for the material. It was not made from exotic imported fibers. It was made from local materials, consistent with manufacture by people who were familiar with the local environment of the Red Sea region. The third category of material, the mineral sealant, is perhaps the most technically significant because it speaks to a level of boat-building sophistication that goes beyond simple raft construction. The material in question is a dark, tarry substance found on some of the wood fragments, coating their surfaces and filling some of the joints and gaps between pieces. Chemical analysis has identified it as a bitumen-based compound, a natural petroleum product similar to the material used as a sealant and adhesive in boat-building traditions throughout the ancient Middle East. Bitumen occurs naturally in various locations around the Red Sea region, seeping from subsurface petroleum deposits, and its use as a waterproofing compound is one of the oldest known applications of a petroleum product by humans. Archaeological evidence for the use of bitumen as a waterproofing agent in boat building has been found at sites in the Persian Gulf region dating back to at least 7,000 years ago, but the Red Sea material would push that evidence back by more than 23,000 years. The use of bitumen as a waterproofing agent in boat building is not a trivial technological step. It requires knowing where bitumen can be found, how to collect it, how to heat and process it to the right consistency, how to apply it to wooden surfaces, and how to combine it with other materials, fiber or sand, to improve its mechanical properties. This is practical chemistry, developed through observation and experimentation, and it implies a degree of accumulated technical knowledge that goes well beyond the basics of watercraft construction. Taken together, the three categories of material, worked wood with joinery features, fiber cordage, and bitumen sealant, paint a consistent picture. They are the basic components of a type of watercraft construction that has been used throughout the ancient world. They are not individually definitive proof that the material came from boats. Any one of them could theoretically be explained as the remains of some other kind of wooden structure. But their occurrence together in close proximity at the bottom of the Red Sea, dating to 30,500 years ago, is a combination of facts that is very difficult to explain without reference to some form of watercraft. The question of how this material ended up at the bottom of the Red Sea Rift Zone, at depths of more than 1,000 meters, is one that needs to be addressed directly. It is a legitimate scientific question, and the answer matters for how we interpret the evidence. There are essentially three possible mechanisms by which material originating at the surface or near the surface of the Red Sea could end up at those extreme depths. The first is transport by ocean currents. The Red Sea has a complex circulation pattern, with surface currents driven by wind and by the exchange of water with the Indian Ocean through the Bab el-Mandeb Strait. Under certain conditions, material floating at the surface could be transported by these currents to areas directly above the rift zone, where it could sink and accumulate. The second mechanism is direct sinking from an event that occurred at or near the surface, the capsizing or sinking of a vessel, for example, or the collapse of a coastal structure into deep water. The third is transport by submarine landslides or turbidity currents, underwater avalanches of sediment that can carry material from the shallow continental shelf into the deep rift zone. All three mechanisms are physically plausible. The question of which one actually delivered the material to its current location requires an examination of the spatial distribution of the finds and the characteristics of the surrounding sediments. The spatial distribution of the material in the Red Sea Rift Zone is not random. It is concentrated in a specific area of the Rift Valley floor, in a pattern that is more consistent with a single depositional event or a small number of related events than with the gradual accumulation of material transported by currents over a long period. The material clusters around a specific area with dimensions of roughly a few hundred meters, which is small relative to the vast extent of the rift zone. This clustering is more consistent with the sinking of a specific source, one or more watercraft, than with the random accumulation of current-transported material. The characteristics of the sediments surrounding the finds also provide evidence. The material is found within a specific sediment layer that is consistent with the time period indicated by the dating results, a layer that represents the seafloor surface at approximately 30,500 years ago, now buried beneath subsequent sediment accumulation. This stratigraphic positioning, the material being found at a specific depth within the sediment column, consistent with the dated age, is important evidence that the material was deposited at the seafloor at approximately the time indicated by the dates, rather than being transported by later processes and incorporated into older sediments. The geology of the rift zone in the area where the material was found does not show the characteristics typical of turbidity current deposition. The grading of sediment particle sizes, that is the hallmark of turbidity current events, is not present in the sediments immediately associated with the finds. This makes submarine landslide transport a less likely explanation for the deposition of the material. Taken together, the spatial clustering, the stratigraphic positioning, and the absence of turbidity current signatures are consistent with the material having arrived at the rift zone floor by direct sinking, either from the surface, as the wreck of one or more vessels, or from a depth of several hundred meters as material that had been displaced from its original position on the ancient coastline by some more localized event. The direct sinking interpretation is the simplest explanation that is consistent with all of the available evidence. Now let us turn to a set of questions that go beyond the specific evidence from the Red Sea. Let us ask what the broader archaeological and genetic record tells us about the capabilities and the movements of human populations in the Red Sea region during the relevant period. Because the material evidence from the rift zone does not exist in isolation, it needs to be understood in the context of what we know about the people who might have produced it. The genetic record of human populations is a rich source of information about the movements and interactions of ancient human groups. Modern genetic analysis, particularly the analysis of ancient DNA extracted from skeletal remains found at archaeological sites, has transformed our understanding of prehistoric human population history over the past 2 decades. The results have been consistently surprising, revealing levels of long-distance migration, inter-population contact, and genetic complexity that far exceed what was previously suspected based on the material culture record alone. For the Red Sea region specifically, the genetic record points to a complex history of population movements that extends back tens of thousands of years. The genetic signatures of modern populations on both sides of the Red Sea, in northeastern Africa and in the Arabian Peninsula, show evidence of repeated episodes of gene flow across the Red Sea, in both directions, over a period spanning at least the last 60,000 years. This gene flow, the mixing of genetic material between populations on opposite shores of the Red Sea, implies repeated contact between those populations, which in turn implies repeated crossing of the Red Sea. It is important to understand what these genetic signals mean in concrete terms. When population geneticists detect gene flow between 2 populations, they are detecting the signature of actual people moving between those populations, actual human beings crossing the geographical barrier between their respective homelands and having children with people from the other group. In the case of the Red Sea, the barrier is a body of open water. The only way to cross it before the age of modern bridges and tunnels is by boat. Every genetic signature of gene flow across the Red Sea is a signature of boat building and navigation. The genetic evidence for gene flow across the Red Sea extends back at least 60,000 years, and it shows periods of increased contact that correspond to specific environmental conditions, periods when the climate was favorable, when the Bab el-Mandeb Strait was narrower due to lower sea levels, and when the environments on both sides of the Red Sea were productive enough to support population growth and expansion. The period around 30,500 years ago falls within a phase of relatively complex climatic conditions, a period of fluctuating temperatures and precipitation as the Ice Age was building toward its peak, but it is not climatically an implausible time for cross-Red Sea contact and navigation. The archaeological record from the land sites around the Red Sea during this period provides additional context. Sites in northeastern Africa, in the Nile Valley and along the Ethiopian highlands, show evidence of sophisticated stone tool technologies, the Middle Stone Age traditions of Africa that are associated with the first expressions of fully modern human behavior at dates well before 30,500 years ago. Sites in the Arabian Peninsula, while more sparsely documented, show evidence of human habitation during wet periods when the Arabian interior was habitable. And the coastal regions on both sides of the Red Sea, while largely submerged and therefore inaccessible to direct excavation, are known from the genetic and indirect archaeological evidence to have supported human populations throughout this period. The picture that emerges is of a Red Sea region that was, during the relevant period, a zone of active human habitation and movement. People were living on both coasts. People were crossing between the coasts. The genetic evidence demands this. And if they were crossing, they were using some form of watercraft. The question is not whether they had watercraft. The question is how sophisticated those watercraft were. And the material evidence from the rift zone, if it is correctly interpreted, suggests an answer. Sophisticated enough to use joinery techniques, sophisticated enough to use bitumen waterproofing, sophisticated enough to deserve the term fleet in the sense of multiple vessels operated as part of a coordinated maritime activity. Let us now take a different kind of detour, not to the bottom of the ocean, but to the surface of the desert and to the sky above it. Because one of the most powerful tools we now have for finding evidence of ancient human activity on land and potentially underwater is remote sensing from above. Satellite imagery, airborne radar, and other forms of aerial observation that can detect features invisible to eyes on the ground. The use of satellite imagery and aerial photography in archaeology has a long history, dating back to the early days of flight when archaeologists realized that features invisible at ground level, field boundaries, buried foundations, ancient trackways, could be seen clearly from the air, their presence revealed by subtle differences in crop growth or soil color. In the 20th century, this approach was refined and expanded, and the advent of satellite remote sensing has brought it to an entirely new level of sophistication. Modern satellite remote sensing can detect not just the kind of subtle surface features that were the domain of early aerial archaeology, but structures buried beneath meters of soil or sand. Synthetic aperture radar, SAR, can penetrate dry soil and sand to depths of several meters, revealing buried structures that have no surface expression at all. LIDAR, light detection and ranging, can strip away the vegetation cover of dense forests to reveal the topography of the ground beneath, exposing ancient earthworks and structural remains hidden by centuries of jungle growth. The application of these technologies to the problem of finding ancient sites in the regions surrounding the Red Sea has produced some remarkable results. In the Arabian Peninsula, satellite radar surveys have revealed networks of ancient pathways, tracks worn into the desert surface by the movements of people and animals over long periods of time that predate any known archaeological site in the area. In northeastern Africa, remote sensing has identified previously unknown concentrations of ancient stone structures in areas of the Sahara that are now far too dry to have supported human habitation without the climate change that characterized the Green Sahara period. These discoveries tell us that the region around the Red Sea was far more densely and extensively inhabited in the past than the currently known archaeological record suggests, and they reinforce the probability that the coastal regions of the ancient Red Sea, now submerged, were among the most heavily populated areas of this ancient inhabited landscape. The underwater equivalent of these aerial remote sensing techniques, the multi-beam sonar and sub-bottom profiler technologies we discussed in Part 1, are now being applied systematically to the continental shelves of the world's oceans, and the results are beginning to come in. What is being found with increasing regularity is evidence of ancient human activity on the submerged continental shelves, not just in the specific cases we have already discussed, but across the world's coastlines. Ancient river channels now submerged beneath the sea that show signs of having been inhabited along their banks, concentrations of worked stone tools on the shallow continental shelf indicating ancient camps and workshops, buried soil horizons, ancient ground surfaces that contain the chemical signatures of human occupation. And in a growing number of cases, actual structural remains, walls, platforms, and other built features that can only be explained as the products of deliberate human construction. One of the most intriguing recent discoveries in this rapidly developing field of underwater archaeology involves not the Red Sea or the Caribbean but the Mediterranean, specifically the seafloor of the Mediterranean Sea off the coast of what is now the island of Sicily. In 2015, researchers conducting a routine oceanographic survey of the shallow waters of the Sicilian Channel, the narrow stretch of water between Sicily and Tunisia, discovered something that immediately commanded attention. At a depth of approximately 40 meters, lying on the seafloor in a state of partial burial by sediment, a massive stone monolith. A single piece of stone, roughly 12 meters long, weighing an estimated 15 tons and clearly shaped by human hands. The monolith is made of limestone, and it is clearly not in its original geological position. It does not match the surrounding geology, indicating that it was quarried from somewhere else and transported to its current location. It has a hole drilled through it near one end, a perfectly round aperture approximately 30 centimeters in diameter, which has no obvious natural explanation. And it has been broken, whether by the geological processes associated with its submersion, or by deliberate human action, or by some other agency is not clear, into two pieces, though the pieces are clearly parts of the same original object. The dating of the monolith and the sediments in which it is partly buried has placed its submersion at approximately 9,500 years ago, right at the period when sea levels in the Mediterranean were rising rapidly as the last vestiges of the Ice Age's ice sheets melted. The monolith itself cannot be directly dated, but the sedimentary context suggests it was deliberately placed in its current location, at a time when the seafloor on which it now rests was dry land. It was on a beach or in a shallow coastal wetland, and the rising sea covered it. Who made it? Who shaped and transported a 15-ton stone slab to a coastal location 9,500 years ago? This was the period of the Mesolithic in the central Mediterranean, the era before farming had reached the region, when the people of Sicily and North Africa were still living as hunter-gatherers and fishers, using stone tools and leaving behind the kind of modest archaeological traces that we associate with mobile, non-sedentary peoples. And yet here is a monolith that would have required significant organized effort to quarry, shape, transport, and erect, a level of social organization and technological capability that is not generally associated with Mesolithic Mediterranean populations. The Sicilian monolith is not unique. Across the Mediterranean and the Atlantic coasts of Europe, similar discoveries have been made in shallow coastal waters, worked stone, monumental structures, evidence of deliberate human activity, at depths consistent with the rise in sea levels since the end of the Ice Age. The Atlantic coastline of what is now Portugal and Spain has yielded submerged megalithic structures in shallow coastal waters. The Adriatic Sea has yielded submerged walls and platforms near the coastlines of Croatia and Italy. The waters around the British Isles have yielded submerged peat layers with human footprints, submerged forests with felling marks on the stumps, and concentrated assemblages of stone tools that represent submerged campsites and workshop areas. The cumulative picture is becoming undeniable. The submerged continental shelves of the world's oceans contain a vast and largely unexplored archive of human prehistory. The people who lived on the ancient coasts were real, they were numerous, and they were doing things, building things, transporting things, organizing things that challenge our conventional understanding of prehistoric human capabilities. Now let us look at what the world's great mythological traditions have to say about all of this. Because across the world's cultures, from the ancient Mesopotamians to the native peoples of the Pacific Northwest, from the Greeks of the classical era to the ancient peoples of India, from the Maya of Central America to the Aboriginal peoples of Australia, there is a strikingly consistent tradition of stories about a great flood. A catastrophic inundation that destroyed a previous world, a world of greater sophistication and achievement than the present one, a world that now lies beneath the waters. The Mesopotamian flood myth, which predates and likely influenced the biblical account of Noah's Ark, describes a great flood sent by the gods to destroy humanity, survived by a single righteous man, Utnapishtim in the Epic of Gilgamesh, who built a great boat to preserve himself, his family, his livestock, and the seeds of all living things. The flood in this account covers the entire land, destroying all that had been built, and the world that emerges afterward is described as lesser than the one that was destroyed. The Vedic texts of ancient India describe a great flood survived by Manu, the first man, who was warned of the coming deluge by a divine fish and built a boat to survive it. The fish then guided Manu's boat to a mountain in the north, where it grounded when the waters receded. The world that Manu repopulated after the flood was, again, implicitly a diminished version of what had come before. The Aztec tradition describes 5 successive suns or world ages, each of which ended in a catastrophe, and one of these catastrophes is a great flood, which destroyed the 4th sun and most of its inhabitants. The survivors of the flood founded the current world age. In the mythology of the Haida people of the Pacific Northwest coast of North America, the world was once very different. The sea was much lower, and vast areas of land that are now submerged were inhabited. A great flood, described as a rapid rise of the sea, covered the land and drove the people to the mountains, changing the world forever. In the traditions of the Aboriginal peoples of Australia, there are strikingly specific accounts of landscape features, islands, bays, reefs that are described as having once been part of the land before the sea rose and covered them. When researchers have compared these oral traditions with the geological record of sea level change in the relevant areas, they have found remarkable correspondences. The features described in the oral traditions as having been submerged correspond to features that would indeed have been above water and accessible during lower sea level stands thousands of years ago. The Aboriginal oral traditions appear to preserve genuine geographical memory of the coastlines of the Ice Age, transmitted across more than 10,000 years of cultural continuity. This last point deserves emphasis. The Aboriginal peoples of Australia have maintained continuous cultural traditions for at least 65,000 years, the longest unbroken cultural lineage in human history. If their oral traditions preserve accurate geographical memory of coastlines that were submerged more than 10,000 years ago, this is direct evidence that oral tradition can preserve accurate historical information across timescales that most historians would consider impossibly long. And if oral tradition can preserve accurate coastal geography across 10,000 years, it can also preserve in distorted, mythologized form the memory of the great civilizations and the great capabilities that were lost when those coasts were drowned. The convergence of flood myths across the world's cultures is not a coincidence. It is not, as some religious traditions maintain, the echo of a single divine event. It is the accumulated memory of many coastal peoples around the world who watched the sea rise and swallow their world, who saw their homelands, their cities, their sacred places, their ancestors' graves disappear beneath the advancing water. Some of those peoples had sophisticated maritime cultures, capable of building the kinds of vessels that left remains in the Red Sea Rift Zone. And when their world was drowned, the survivors carried the memory of it forward in their stories, their myths, their traditions fragmentary, distorted by time and the inevitable transformations of oral transmission, but fundamentally real. Let us now consider another extraordinary body of water, one that has been generating archaeological surprises with increasing frequency as marine technology has improved. The Baltic Sea, the shallow, semi-enclosed sea that lies between Scandinavia, the German and Polish coast, and the Baltic states, is like the Black Sea, unusual in its chemistry and its history. During the Ice Age, the Baltic basin was covered by the Scandinavian ice sheet. It was not a sea at all, but a deep basin beneath kilometers of ice. As the ice melted, the basin filled first with fresh water from meltwater, creating a large freshwater lake, Lake Ancellus, in the geological literature, before eventually being connected to the North Sea and Atlantic Ocean, and becoming the brackish sea it is today. This complex geological history has created a fascinating and heterogeneous seafloor environment, with layers of different sediment types corresponding to the different phases of the basin's history. In 2011, a team of divers and marine archaeologists working off the Swedish coast made a discovery that generated enormous media attention and considerable scientific debate. At a depth of approximately 85 meters in the southern Baltic Sea, the sonar on their research vessel showed what appeared to be a circular structure on the seafloor, about 60 meters in diameter. The circular form was regular and well-defined, rising about 3 to 4 meters above the surrounding seafloor. Its edges were remarkably distinct, and its overall appearance, a perfect circle with well-defined margins sitting in the featureless flat expanse of the Baltic seafloor, was unlike any known natural geological formation. The team sent down ROVs to examine the structure at close range, and what they found both clarified and complicated the mystery. The structure was made of stone, not sediment, a collection of large rocks and boulders arranged in a circular form. The rocks showed evidence of having been moved from their original positions. They were not in geologically natural locations. Some of them showed dark marks on their surfaces that could potentially be interpreted as evidence of fire. If rocks are heated and then exposed to water, they can show characteristic thermal fracturing and discoloration. And the circular arrangement of the stones was, at minimum, highly unusual. The media quickly dubbed the discovery the Baltic Sea Anomaly, and speculation ran wild, including some extremely fanciful claims about spacecraft and alien technology that we will not dignify by repeating here. But the serious scientific question, what is this structure and how did it form, deserves a serious answer. There are several plausible explanations for the Baltic Sea Anomaly that do not require invoking the supernatural or the extraterrestrial. The most widely accepted current explanation among marine geologists is that the structure is a natural formation created by the geological processes associated with the Ice Age. Specifically, it may be a formation left by the edge of the Scandinavian ice sheet, a moraine, formed when the ice sheet was stationary for a period and deposited a ridge of rock debris at its margin. Circular or arc-shaped moraine formations are known from the Baltic region, and the approximately circular shape of the Baltic anomaly could be consistent with a particularly well-preserved example of this type of formation. The alternative interpretation, that the structure is a human-made formation, either a deliberate arrangement of stones with some cultural or functional purpose, would require it to have been created at a time when the seafloor on which it sits was above water. Given the current depth of 85 meters, and accounting for the isostatic rebound of the Scandinavian region, the land rising as it is freed from the weight of the ice sheet, the the structure would have been above water during the late Paleolithic or early Mesolithic period, perhaps 10,000 to 14,000 years ago, depending on the exact local rate of isostatic uplift. 10 to 14,000 years ago, the Baltic Basin was a landscape of tundra and boreal forest, inhabited by hunter-gatherer populations who followed the retreating ice sheet northward and exploited the rich resources of the post-glacial environment. These people, the ancestors of the modern Scandinavian and Baltic populations, at least in part, were capable of organized activity, including the construction of structures from stone. We know this from their burial sites, their camp remains, and their tool assemblages found on dry land in the region. The construction of a circular stone arrangement 60 meters in diameter would not be beyond the organizational capability of a reasonably large Mesolithic community. Whether the Baltic Sea anomaly is a natural moraine formation or a human-made stone arrangement, it is a reminder that the Baltic seafloor, like the floors of all the world's shallow seas, contains features that have not yet been examined in sufficient detail to be definitively explained. The area surveyed in any detail by ROVs and high-resolution sonar represents a tiny fraction of the Baltic's total area, and there is every reason to expect that more surprising features will be found as surveys continue. One of the most reliably productive areas for underwater archaeological discovery in the past 2 decades has been the waters of the Eastern Mediterranean. The Mediterranean is an ancient sea, ancient in the sense of human history, a body of water that has been sailed, traded upon, fished, and fought over for at least 10,000 years. The civilizations that rose and fell around its shores, the Minoans, the Mycenaeans, the Phoenicians, the Greeks, the Carthaginians, the Romans, the Byzantines, all were maritime civilizations, dependent on the sea for their economic life and their political power. They put enormous numbers of vessels onto the Mediterranean, and a significant fraction of those vessels went to the bottom. The Mediterranean is also, in its deepest parts, a well-preserved archive. While it is not anoxic in the same way as the Black Sea, the Mediterranean's deep water does contain dissolved oxygen, though at lower levels than the surface. The cold, calm conditions at great depths do slow the processes of decomposition and provide reasonable preservation of organic materials over archaeological timescales. And the Mediterranean's relatively enclosed geography and the intensity of maritime trade that has occurred on its waters make it one of the world's richest environments for underwater archaeological discovery. Among the many remarkable discoveries that have been made in Mediterranean waters in recent years, one of the most scientifically significant was the investigation of a series of circular patterns on the seafloor off the coast of the Sicilian island of Pantelleria, not far, as it happens, from the monolith we discussed earlier. In 2011, divers exploring the shallow coastal waters of the island discovered what appeared to be circular arrangements of stones on the seafloor at depths of between 8 and 20 meters. The circles ranged in diameter from a few meters to several tens of meters, and they were composed of rounded stones carefully arranged in distinct circular patterns. The initial reaction of the scientific community was a combination of excitement and skepticism. Circular stone arrangements are known from many contexts. They can be the foundations of circular structures. They can be the result of certain types of fishing weir construction. They can be the product of specific ritual or ceremonial activity, or they can be natural features created by certain types of biological or geological process. Determining which of these explanations applied to the Pantelleria circles required careful investigation. The investigation that followed revealed something genuinely interesting. Analysis of the stone arrangements, combined with dating of the biological material associated with them, suggested that the circles were not the result of human construction at all, but neither were they the result of random natural processes. Instead, they appeared to be the result of a specific biological phenomenon, the growth patterns of a type of coralline algae, a marine plant that builds calcium carbonate structures under conditions of low light and specific water chemistry. During periods of lower sea level, when the seafloor in the area was in shallower water with different light conditions, the coralline algae had grown in circular patterns, creating ring-like structures that were then preserved as the sea level changed and the conditions no longer favored their growth. The circles were, in a sense, frozen in time biological artifacts of a past environmental condition, preserved in the shallow seafloor and only now being discovered and understood. This explanation, both mundane and fascinating in its own right, illustrates something important. Not every mysterious underwater structure is a product of human activity. The natural world is fully capable of producing forms that superficially resemble human construction, and distinguishing natural from human-made features requires careful, methodical investigation rather than immediate conclusions based on visual impressions. This is a point that applies equally to the more controversial cases we have been discussing, the Cuban structures, the Yonaguni Monument, and it is why proper scientific investigation of these sites is so important. But let us now return to the central mystery, the 30,500-year-old material from the Red Sea Rift Zone, and address the question that sits at the heart of the controversy. Even if the material is genuine, even if it really is the remains of ancient watercraft, what does it tell us about the society that produced it? What kind of people were these? How did they live? And what happened to them? The last question is, in some ways, the easiest to answer. We know what happened to the coastal civilizations of the Ice Age in general terms. The seas rose and covered their world. The process was not uniform. It happened in pulses, with periods of rapid rise alternating with periods of relative stability. But the overall trend was relentless, and its effects on coastal human populations must have been profound. Imagine living on the shore of the ancient Red Sea 30,500 years ago. Your community has been in this place for generations, perhaps for hundreds of generations. You know the coastline intimately, you know the seasonal rhythms of the sea, you know where the fish run and where the shellfish beds are and where the fresh water springs bubble up near the shore. Your boats, the products of accumulated generations of boat-building knowledge, ride at anchor in a sheltered cove. Your community is not large by modern standards, perhaps a few hundred people, but it is sophisticated. It has knowledge, it has traditions, it has continuity. And then over the decades and centuries that follow, you begin to notice that the sea is rising. Slowly at first, a few centimeters per year, barely perceptible over a single lifetime. But the elders remember that the beach used to extend further than it does now. The shellfish beds that were once accessible by wading are now in water above your waist. The campsite where your grandparents' used to gather in summer is now several feet below the waterline. The sea is coming in and nothing can stop it. Your community adapts. You move your camps back from the shore. You establish new fishing grounds in the areas that are still accessible. You modify your boats to work in slightly different conditions as the harbor geometry changes. You carry on, but the sea keeps rising. Each generation lives with a coastline slightly different from the one their parents knew. And eventually, over centuries, over millennia, the world that your ancestors inhabited is gone, buried under meters of salt water, and the knowledge they accumulated, the structures they built, the boats they crafted, all of it is beneath the waves. Except for what the brine pools preserve, except for what the anoxic sediments hold. Except for what the fragments of worked wood and twisted fiber and bitumen-coated timber tell us, thousands of years later, when the technology to find them and interpret them finally exists. This is not a story of sudden catastrophe. It is a story of slow, inexorable loss, a loss so gradual that no single generation would have experienced it as a crisis, but so total that the civilization that once lived on those shores left almost no trace above the waterline. The only reason we know anything about them at all is because the extraordinary preservation conditions of the deep Red Sea saved a few fragments of what they made, and because the technology of the 21st century has finally made it possible to find those fragments and understand what they are. The implications of all this for science, for history, for our understanding of ourselves as a species are profound. And they extend beyond the specific question of who was sailing the Red Sea 30,500 years ago. They extend to a fundamental rethinking of the human story. The conventional narrative of human history is a story of linear progress. Primitive hunter-gatherers living in small bands using simple stone tools gradually developed more sophisticated technologies and social organizations over tens of thousands of years, until approximately 10,000 years ago, agriculture is invented, populations grow, cities arise, writing is developed, and civilization begins. Everything before agriculture is prehistory, a dark time of simplicity and limitation, interesting to scientists but irrelevant to the main story of human achievement. This narrative is wrong. Not in its basic facts. Agriculture really was developed around 10,000 years ago. Cities really did arise in its wake. Writing really was invented, but in its framing and its implications. It implies that the tens of thousands of years before agriculture were a time of stasis, of limited capability, of small-scale life without significant achievement. And the growing body of evidence from underwater archaeology, from genetics, from the deep history of the Red Sea region and the coastal regions of the world, tells us that this implication is false. Before agriculture, there was a long period of sophisticated coastal adaptation, a period in which human communities developed detailed knowledge of marine environments, constructed watercraft capable of open ocean navigation, established trade networks across bodies of water, and accumulated the kind of practical knowledge of the natural world that is, in its own way, just as sophisticated as the knowledge systems of the civilizations that came later. That period of coastal sophistication is poorly represented in the archaeological record, not because it did not exist, but because its sites are underwater. The Ice Age was not a time of uniform primitivity. It was a time of diversity, of many different human adaptations to many different environments, some of which were more sophisticated than the conventional narrative acknowledges. And when the Ice Age ended and the seas rose, many of the most sophisticated of those adaptations, the coastal ones, were literally washed away, leaving a biased sample of the past that has led us to systematically underestimate the capabilities of our ancient ancestors. Recognizing this is not just a matter of historical accuracy. It has implications for how we think about the range of human possibility, about the relationship between environmental conditions and cultural sophistication, about the role of catastrophe and loss in shaping the trajectory of human history. And it has implications for how we conduct archaeology, for the urgency and the importance of bringing the tools of marine science to bear on the problem of recovering the lost history that lies beneath the seas. Let us now consider one more remarkable ocean environment, one that we have not yet discussed in detail, and what it tells us about the extraordinary diversity of life and the extraordinary capacity of ocean environments to preserve and generate complexity. We are talking about the deep ocean floor itself, the abyssal plain, and the hydrothermal vent communities that inhabit it. Hydrothermal vents are one of the great scientific discoveries of the 20th century. First observed in 1977 by a team of oceanographers using the submersible Alvin to explore the seafloor of the Galapagos Rift, they are places where seawater percolates down through cracks in the ocean floor, is heated by the magma beneath, and erupts back out as superheated water rich in dissolved minerals. The water emerges at temperatures up to 400 degrees Celsius, far above the normal boiling point of water, but kept liquid by the enormous pressure at depth. As it mixes with the cold ocean water, the minerals in the superheated water precipitate out, forming the distinctive chimneys and columns of mineral deposit that give the most dramatic vents their popular name, black smokers. What astonished the scientists who discovered the first vent communities was not the vents themselves, hydrothermal activity on the seafloor had been theoretically predicted, but the life that surrounded them. In the deep ocean, far beyond the reach of sunlight, in a world that was supposed to be essentially lifeless except for the sparse rain of organic material falling from the sunlit surface waters above, the vents were surrounded by an extraordinary abundance of life. Giant tube worms up to 2 meters long, clustering around the vent openings, dense mats of microorganisms covering every surface, clams with blood-red flesh. Crabs, shrimp, fish, and a host of other invertebrates, all living at densities comparable to the richest shallow water reef environments. This life had no connection to the sun. It was entirely powered by chemistry, specifically by the process of chemosynthesis, in which microorganisms use the chemical energy of hydrogen sulfide and other compounds released by the vents to produce organic matter, in exactly the way that plants use sunlight in photosynthesis. The microorganisms form the base of a food web that supports the entire vent community, a complete, self-contained ecosystem running entirely on the energy of the Earth's interior rather than the energy of the sun. The discovery of hydrothermal vent communities fundamentally changed our understanding of the conditions necessary for life. Before 1977, it was generally assumed that life required sunlight directly or indirectly to survive. The vent communities showed that this assumption was wrong. Life can exist in great diversity and abundance in the complete absence of sunlight, powered by chemical energy rather than light energy. This has profound implications for the search for life elsewhere in the solar system, on icy moons like Europa and Enceladus, which may have liquid water oceans beneath their frozen surfaces, warmed by tidal heating from their planetary parents and potentially hosting hydrothermal vent systems similar to those of Earth's deep ocean. But the discovery of vent communities also has implications for our understanding of the origins of life on Earth. The conditions at hydrothermal vents, the chemical richness, the energy gradients, the interfaces between hot and cold water, are similar in some ways to the conditions that prebiotic chemistry researchers believe characterized the early Earth before life first emerged. Some researchers have argued that life on Earth may have originated at hydrothermal vents, that the first living cells formed in the chemically rich, energetically active environment around early Earth's hydrothermal vent systems. If this is true, then the vent communities we see today are not just extraordinary examples of adaptation to extreme environments. They are living representations of the conditions in which life itself began, and this brings us back in a way to the brine pools of the Red Sea. The brine pools are not hydrothermal vents, they are a different type of extreme environment created by a different set of geological processes. But like the vent communities, they host life that uses energy sources other than sunlight, life that has adapted to conditions that would be lethal to most organisms, life that represents some of the oldest and most primitive metabolic strategies known. The brine pools and the hydrothermal vents together illustrate a fundamental truth about life on Earth. It is far more resilient, far more adaptable, and far more diverse than we intuitively expect. Life does not give up easily. It finds ways to persist in conditions that seem impossible, using strategies that evolve in response to whatever resources are available. The ancient humans who may have sailed the Red Sea 30,500 years ago were, in a very real sense, exhibiting the same quality that the extremophiles of the brine pools exhibit: adaptability, the ability to find ways to exploit environments and opportunities that seem, at first glance, beyond reach. The Red Sea is a challenging environment, subject to intense heat, strong winds, unpredictable currents, and the constant hazard of sudden storms. Navigating it in an ancient wooden vessel required skill, knowledge, courage, and the accumulated wisdom of generations. It was not an environment that conquered easily or cheaply, and yet the evidence suggests that ancient humans were out there, on the water, in the waves, carrying whatever it was they needed to carry from one shore to the other. That human quality, the stubborn, inventive, courageous refusal to be stopped by the obstacles nature puts in the way, is perhaps the most important thing to take away from this exploration. The ocean tried to keep its secrets. The rising seas buried the evidence. The pressure and the darkness of the deep water seemed to make recovery impossible. And yet here we are with technology that can find a sliver of worked wood at the bottom of a 1,000-meter deep brine pool and tell us with reasonable certainty that a human hand shaped it 30,000 years ago. Now let us talk about what comes next, because the story we have been telling throughout this documentary is not a complete story, it is a beginning. The evidence for a 30,500-year-old maritime culture in the Red Sea is real, but it is fragmentary. The anomalous structures off Cuba and at Yonaguni are real, but they are not yet fully investigated. The submerged coastlines of the world's continental shelves are real, but they are barely explored. What comes next, what the next decades of underwater archaeological research will bring, has the potential to be one of the most transformative episodes in the history of science. The technology is ready. The multi-beam sonar systems, the autonomous underwater vehicles, the remotely operated vehicles, the advanced DNA sequencing techniques, the isotopic dating methods, all of these tools are available today and they are improving rapidly. What has been lacking in many cases is the will and the funding to apply them systematically to the problem of recovering the lost history of the world's submerged continental shelves. That is changing. The recognition that the continental shelves contain vast amounts of archaeological information, a recognition driven partly by discoveries like those we have been discussing in this documentary, is gradually making its way into the mainstream of archaeological funding and planning. International programs for the systematic survey of the world's continental shelves are beginning to be organized. Deep-sea archaeological expeditions, once the exclusive domain of well-funded national research programs, are becoming more accessible as the cost of ROV technology decreases and as private philanthropic funding for ocean exploration increases. What might the next generation of underwater archaeological research reveal? Let us think through some of the specific possibilities. The Red Sea itself, particularly the central rift zone where the controversial material has already been found, is an obvious priority. A systematic, targeted archaeological survey of the Red Sea rift zone, using the best available technology and conducted by a team that includes both marine archaeologists and geologists, could definitively characterize the nature of the material already found and search for additional evidence. If the material is indeed the remains of ancient watercraft, a more extensive survey might find associated artifacts, stone tools, food remains, personal ornaments that would paint a much more detailed picture of the people who made the vessels. It might find multiple sites, suggesting a pattern of maritime activity rather than a single isolated event. It might even find material that gives us a clearer view of what kind of vessels these ancient mariners were operating. The submerged continental shelf of the Persian Gulf is another extremely high-priority target. As we discussed in the first part, the Persian Gulf was dry land during the peak of the Ice Age, traversed by a great river and inhabited by substantial human populations. The flooding of the Persian Gulf Valley between 14,000 and 8,000 years ago, coinciding, as we noted, with the time period of the Mesopotamian flood myths, would have driven those populations northward and potentially transformed their society in fundamental ways. Archaeological investigation of the submerged Persian Gulf floor could find the antecedents of the Mesopotamian civilizations, the communities that preceded the Sumerians and the Babylonians, whose existence has been inferred from genetic and indirect evidence, but never directly confirmed through archaeology. The Sunda Shelf of Southeast Asia, the vast submerged continental shelf that was dry land during the Ice Age, and that connected Sumatra, Java, Borneo, and the Malay Peninsula, is perhaps the largest single area of submerged prehistoric landscape in the world. It was inhabited for tens of thousands of years by populations that are the ancestors of the modern peoples of Southeast Asia, and it was home to some of the oldest genetic lineages in the world outside of Africa. Archaeological investigation of the Sunda Shelf could reveal an entire chapter of prehistoric human history that is currently almost completely unknown. And the Atlantic coast of northwestern Africa, the coastline of Mauritania, western Sahara, and Morocco, presents the possibility of finding direct physical evidence for the theory connecting the Richat structure to Atlantis. The shelf off this coastline was significantly wider at lower sea levels, and any coastal settlements associated with a sophisticated culture operating in the Richat structure area during the Green Sahara period might have left remains now lying on the submerged shelf. Each of these research programs would require significant resources, years of ship time, large teams of scientists, expensive technology, but the potential returns are proportional to the investment. We are talking about the possibility of recovering lost chapters of human history, chapters that span the gap between the earliest known complex behaviors of modern humans and the emergence of the first documented civilizations, chapters that would fundamentally reshape our understanding of who we are and what our species is capable of. Let us now take a moment to consider what it means to be the species that is capable of asking these questions. We are the only species on Earth that looks at the ocean and asks, "What secrets are you keeping?" We are the only species that builds machines to descend into the darkness and look. We are the only species that takes a fragment of ancient wood from the bottom of a 1,000-meter deep brine pool and asks, "Who made this, and how old is it, and what were they doing when they made it?" That questioning instinct, the insatiable human curiosity about the past, about our origins, about the full extent of our story on this planet, is itself one of the most remarkable things about us. It is what drives the marine archaeologist to spend years learning the technology of deep-sea exploration in order to spend a few precious hours at the bottom of the Red Sea looking at pieces of ancient wood. It is what drives the geneticist to spend months sequencing and analyzing ancient DNA from fragments of bone found in a cave, in order to learn something about the movements of people who lived 100 generations ago. It is what drives the oceanographer to spend weeks aboard a research vessel in the middle of the Red Sea, mapping a rift zone that most people have never heard of, hoping to find something that changes the story. That curiosity is our inheritance. It is what our ancient ancestors had when they looked at the far shore of the Red Sea and wondered what was there. It is what drove them to build boats and cross the water. It is what drives us 30,000 years later to descend beneath that same water and look for what they left behind. And the ocean, patient, cold, indifferent, yet somehow keeping faith with the evidence it has preserved, is beginning to answer. Let us close by considering one last extraordinary example of life in the ocean, one that brings together many of the themes we have been exploring, and that serves as a kind of final meditation on what the deep sea teaches us about the nature of time, preservation, and the persistence of life. Deep in the anoxic waters of the Black Sea, in the cold, dark, hydrogen sulfide-rich environment that has no oxygen and no light, living things persist. Certain bacteria, extremophiles of the most extreme variety, have found ways to metabolize the toxic hydrogen sulfide, using it as an energy source in a process that is fundamentally alien to the aerobic biology that characterizes most life on Earth. These organisms are not simply surviving in a hostile environment. They are thriving, they are reproducing, they are evolving. In the depths of the Black Sea, in conditions that would kill most organisms within seconds, life has established a community that has been continuously present for thousands of years, perhaps tens of thousands of years, persisting through the dramatic environmental changes that have transformed the surface world above it. These organisms have never seen sunlight, they have never breathed oxygen. They live in a world defined by pressure, cold, and chemistry rather than light and warmth. And yet they live fully, actively, persistently. They demonstrate that the definition of habitable is far broader than our intuitions suggest. They demonstrate that life is not a fragile thing that can only exist in a narrow band of conditions, but a robust, adaptable, inventive phenomenon that finds ways to establish itself wherever the basic physical and chemical requirements can be met. The same could be said of human culture. Human culture is not a fragile thing that can only exist in the narrow band of conditions represented by the warm, fertile, well-watered environments where the famous ancient civilizations arose. Human culture is robust, adaptable, and inventive. It established itself in Arctic tundra and tropical rainforests, in mountain highlands and coastal lowlands, in deserts and wetlands. It established itself on the shores of the ancient Red Sea 30,000 years ago, and it built boats and it went out on the water, and it survived for generations before the rising sea covered its world. That culture is gone now, its people absorbed into other populations, its specific knowledge lost, its physical remains buried under 1,000 meters of water and sediment. But the people who carried it were our ancestors, all of ours, because all non-African people alive today carry the genetic legacy of the ancient coastal populations who spread out of Africa along the shores of the Indian Ocean and the Red Sea. Their curiosity, their courage, their inventiveness, the same qualities that drove them to build boats and cross open water, are encoded in our biology, passed down through 100,000 generations, still present in us today. When a marine archaeologist descends into the Red Sea and finds a fragment of worked wood from 30,000 years ago, she is not just finding evidence of an ancient culture. She is finding evidence of herself, of the qualities that make her the kind of person who descends into the deep ocean to look for ancient wood in the first place. The curiosity, the courage, the refusal to accept that the ocean's secrets are forever beyond reach. They are not forever beyond reach. We are reaching them now. And what we are finding will change everything. What we know for certain after this journey through the world's most mysterious underwater environments is this: the story of human civilization does not begin 5,000 years ago with the Sumerians and the Egyptians. It does not begin 10,000 years ago with the first farmers. It begins in all its complexity and capability and diversity much, much earlier. On the shores of ancient seas that no longer exist in the forms our ancestors knew, in communities whose physical remains are now buried beneath the ocean, among people who were, in every relevant sense, as fully human as we are, the evidence is fragmentary, it is contested, it requires careful, rigorous investigation before definitive conclusions can be drawn. The 30,500-year-old material from the Red Sea Rift Zone needs to be studied more extensively, with larger sample sizes, more sophisticated analytical techniques, and the kind of multidisciplinary collaboration that only a large, well-funded scientific program can achieve. The structures off Cuba need to be visited and examined by a team combining marine archaeologists and geologists. The Yonaguni Monument needs a comprehensive, dispassionate geological and archaeological survey. The Eye of the Sahara needs targeted archaeological investigation to determine whether the evidence of human habitation there is consistent with the Atlantis hypothesis or points toward a more prosaic interpretation. All of this work needs to be done, and it will be done because the questions are too important and the evidence too compelling for them to be ignored indefinitely. The ocean holds an archive. The archive contains chapters of human history that no one has read in 30,000 years, and we are at last learning to read it. The deep water is dark, but we are bringing light, and what we are illuminating piece by piece, fragment by fragment, work plank by twisted fiber by bitumen-coated joint, is nothing less than the true story of our species on this ancient, water-covered, endlessly surprising planet. The secrets are surfacing, the archive is opening. And the history of humanity, the full history, the real history, the history that includes everything the rising seas tried to hide, is beginning at last to be told. The ocean does not forget. It holds everything that was given to it, the ships and the cities, the bones and the tools, the ropes and the timbers, and the thousands small objects of daily life that fell into its keeping across the long span of human history. It holds them in its cold and dark and patient water, waiting with a patience that puts human patience to shame, waiting for the moment when the creatures on the surface above develop the curiosity and the technology to come looking. That moment is now. We are the generation that will descend into the archive. We are the generation that will read the chapters the ocean has been keeping. And when we do, when the full story is finally assembled, we will know ourselves more truly, more deeply, and more humbly than we have ever known ourselves before. Because the story of what we are is always, ultimately, the story of what we were. And what we were, it turns out, is far more extraordinary than we ever imagined.